And we're live now.
Hello and welcome to the online telescope at Slooh, a worldwide community of members, students, educators, exploring the universe together with our live telescopes while learning about space and astronomy. I'm Paul Cox, your host tonight, and I'm going to be joined by a very special group of expert guests to learn more about the spectacular event we're going to witness over the next few hours. Now, we're going to be watching May's full flower supermoon plunge into the shadow of the Earth for a total lunar eclipse. We'll watch the moon slowly transition between a beautiful white lily, just like most full moons, into this deliciously colored red rose. Some call it a blood moon, but I don't think that's suitable for a flower moon. So I'm going to be thinking of this one as a colorful red rose. For me, this is without doubt actually the best astronomical event of the year so far. We've been bereft of great comets and all sorts of things this year, but this eclipse, it's going to be a good one. Now, while I remember, I must tell you this. I know that we've got a lot of new members coming in tonight. We've got our new family subscription. If you are just joining up over the last few days, then on Tuesday, May 17th at 7 p.m. Eastern time, I'm going to be doing a special getting started session, and that's going to take you through the whole of the online telescope, how to use the telescopes, how to do our quests, which we're going to be learning about later on, and all manner of things. But we have got a screen share coming up. Yeah, so we've what have we got? Actually, let's hop over first of all to the feeds, if we could, studio, because we've got live telescope feeds of this stunning phenomena from Slooh's Canary Islands and Chile observatories, and some special streams from the Institute of Astrophysics of the Canary Islands, and several Slooh members, including Nick Rotunda from Dallas, Fort Worth, Texas, John Larson from Omaha, Nebraska, and Gretchen Bickert from Portal, Arizona. She's not from there, but that's where she is for this eclipse. Now then, we are now going to go over to, sorry, studio. In fact, no, let's stay here. Let's stay here and have a look at some of our live feeds, because we've jumped the gun a little bit on this, but let's have a look. So this is if you are a Slooh member, you'll be able to come to this particular page, which is the Star Party page, and it's probably better, a bit smaller actually, thanks to you. And all of our live feeds tonight, you can snap an image from them. So what we've got here, we've got the Canary half meter. There is the moon. We can't see any eclipse yet because the eclipse is only just starting, but it's the penumbral phase, which is actually really quite weak and very, very difficult to discern. So that's over the next hour. But we've got the Canary 2 wide field telescope. We've got the Canary 3. Now, Canary 3 is the one to keep an eye on tonight. It's going to look absolutely horrible for the first hour, maybe hour and a half. But then this one's going to give us an absolute treat as far as the live views are concerned, because we're going to see this deep, rich color coming into our Canary 3 telescope. We've got the Chile wide field, that's just come online, our Chile observatory. We've got, don't go to mobile 3 yet, studio, because we're waiting for Gretchen. Gretchen's going to be providing that feed, and we won't have images coming through for quite a time on that. Let's go over to Canary all sky, if you wouldn't mind. Let's take a look at the skies over the Canary Islands. Look at this. That looks like a daytime view, but believe it or not, it's not. It's nighttime. Canary Islands, about 300 miles off the west coast of Africa. This is where all of the telescopes that Slooh members control every night are based there, and at the Chile Observatory. And then we can see it looks like daytime blue sky, but that's actually the moon, not the sun. It's going to be really interesting to see whether or not we see a dimming of the moon in this particular view. Studio, have we got the EAT, the Institute of Astrophysics, live video feed that we could have a look at, please? Let's have a look at this. So this is going to be a great feed as well. So this is from our partners, skylive.tv. and our partners at the Institute of Astrophysics at the Canary Islands. And this is a live video feed. We can see there, they've got their timing. An hour's time is when the partial phase starts. That's when we're really going to start seeing a chunk taken out of the moon. And then an hour after that, we've got the total phase starting, and that's when we start seeing the really rich color. We will see some color coming in actually during the partial phases, but anyway, let's just hop back a sec, studio, because we've jumped the gun a bit there. But I want to have a look at the visibility now. If you're lucky enough to see the eclipse in your own backyard, let's take a look at where you need to be to see it in person. It's quite a large area. I'm in the UK at the moment. It's 2:30 a.m. in the morning here, and I've got thunderstorms, so the only views I'm going to get of the blood moon eclipse this evening is on Slooh. So let's have a look at this map. So if you're anywhere in the black area of that, you're going to see the whole thing. If you're in any of those colored zones on the right hand side, you're going to see it as the moon is setting. All right, so you can see maybe where I am in the UK, the total phase, it's actually going to be setting during the total phase. So I am hoping I do get clear skies. If we go over to the left of that diagram, then people on the East Coast see it now, moon's kind of rising. And on the West Coast, though, they're going to have to wait, and it'll be rising under eclipse, so that's going to be quite good. But anyway, if you are within those lines and you've got clear skies, unlike me, you will be able to see this eclipse with your own eyes. But hang around here, because we'll be your audio explanations, because I've got a whole series of great guests coming up as well. So we've actually, let's go back to the live feeds, because I do just want to show one thing, please, studio, because don't forget that Slooh members can snap images from some of those live feeds tonight. You just go to that Star Party page on the website and you flick between those different feeds, and you can then just click the camera button, and that saves that picture to your personal photos area. That's just like Slooh members use the online telescopes every single night. So we normally watch things like galaxies and stars, planets. We see the moon as well, nebulae, stuff like that. And actually, the members who are really wanting to look at those objects tonight are kind of out of luck, because as you saw from that all sky view, the moon has totally illuminated the sky, and it makes a lot of those other images really noisy, but we're going to be good. One thing I would say to everybody today is keep an eye just during this what's called penumbral phase. We're going to go over this in a second, but just keep an eye open during the penumbral phase, because I'm going to be interested to know if you can spot any slight dimming, because that's all we see during the first hour. The real action starts in hour 2. All right, so let's have a look at the eclipse timings, if we may. And then we're going to go to our first guest. So what we've got here is, as I say, the penumbral phase of the eclipse. So the eclipse is underway already. It started 7 minutes ago. Now the partial eclipse begins, and this is when we really start seeing a bite taken out of the moon. That's going to start at 0228 UTC, which is 10:28 PM Eastern. Then the real action starts when the total eclipse begins an hour later. That's at 11:29 PM Eastern. Now I know that is late, but stay up, because it's going to be well worth it. These blood moon eclipses, they just look absolutely fabulous, and they affect a lot of people quite profoundly and spiritually, and we're going to talk about that with one of my guests a little bit later. Talking of guests, that's what we're going to see, but what are we going to learn and discuss with our special guest? Well, we're first of all going to go back to basics with a kind of Lunar Eclipse 101 with our expert member Keith, and then we have another member who's written some of our quests. Now, those are learning activities that students and members can do. We'll learn more about them later, actually, because we've got another guest telling us about that. And Milton is coming on, and he's going to be talking about the cultural aspects of eclipses, in particular, how the Incas saw them. And there's some beautiful storytelling in there. So I hope you stick around for that. This is all coming up in the next hour. And of course, we enjoy all perspectives, of course, here at Slooh, on the online telescope. So we're also going to discuss, just what I was saying a minute ago, how these celestial events can affect us emotionally and spiritually. And Slooh member Gretchen is going to be joining us to discuss that aspect of eclipses. And if you've seen some of our past events, you'll know that solar eclipses, totality, normally brings me to my knees and in tears. But hopefully that's not going to happen tonight, because a lunar eclipse is a far more relaxed affair. Now, we are also going to be joined by one of our most popular ever guests on a Slooh Star Party, astronomy author Bob Berman. Bob is going to be joining us at the beginning of the partial phase and at the start of the total phase. He's an absolute encyclopedia of astronomy and the moon and eclipses. He's probably seen more eclipses than I have years on this planet. So that's going to be great fun to see Bob back. We're also going to be joined as well after all of that, and at the end of the total phase, actually during the end of the partial phase, we're going to be joined by our Slooh members again, and we're going to have a round table discussion then, and we'll just have a good chat and we can answer some of your questions. You've got to forgive me tonight. It's now 2:45 in the morning here in the UK, so I'm trying to caffeine up, but it hasn't obviously taken effect yet. We are also, though, going to learn about how members and students of all ages use Slooh with our Director of Curriculum, Dr. John Beauvais, is going to be joining us. He's going to introduce some of our moon-related quests, where members capture images of the moon to learn about its phases, its features, and even we've got a quest about the Apollo landings, which is quite cool. So anyway, Slooh members, don't forget, you can join us in Zoom and ask questions throughout the event. Pop those into Q&A studio. I'm going to rely on you to relay those to us. So we've got plenty to look forward to. Coming up, though, don't go anywhere. After this really short break, just have a little reset. It'll be about 60 seconds. We'll learn about lunar eclipses with Slooh community expert Keith. So don't go anywhere. Wow, that's just some of the stuff you can get up to when you join the Slooh community to control these telescopes that we're looking at tonight as well. So the studio is going to try and keep up some live feeds for us to have a look at. But anyway, welcome back to the Online Telescope's live coverage of the blood moon full flower total lunar eclipse. It's also a supermoon. And we're going to be with you for the entire eclipse this evening. But now I would like to welcome the first guest. It's Keith Wozaleski, is the first of our community experts joining us to celebrate this wonderful event, to explain what lunar eclipses are and the cause of some of the effects we're going to witness tonight, like the changing color. So Keith, welcome to the Star Party.
Thank you so much for having me, Paul. It's a pleasure to be here.
Now, before we talk about the lunar eclipse, you hold a weekly star party, don't you, for members with Gretchen? When are they, and what do you guys talk about in those?
Yeah, we do. We have a weekly show. This came out of the desire to have, excuse me, shows on Discord for Slooh members, run by Slooh members. So we got together, I don't know, almost a year ago, starting with a lunar phase series of shows, and that carried over into some special themed shows. And we just decided to take it up as a weekly show. We have Jenny on as a guest. Jenny is one of our very keen solar observers. So she usually gives us a report of what's happening with the sun. And then I usually give a planetary report because it seems the moon and planets are definitely in the top 5 objects visited by our Slooh members. And then we look at some images from the Slooh telescopes. We'll look at galaxies. We'll look at nebulae. We discuss things that are happening, current events, in space, like the excitement over this NOVA event that's been happening in M60 and NGC 4647. So, exciting things like that. And I always choose an observation of the week, something that somebody has posted that really strikes me as being noteworthy. And we do the show for about an hour, open discussion, and then we go into the after party, which is where we just kind of talk about everything space related. So it's a lot of fun. We have a good time.
Excellent. You mentioned Jenny there. Jenny gives this great almost narration. She's typing furiously. And the solar telescope. So we've got this solar telescope in the Canary Islands. We look at our sun every weekday, and some of the views there have been absolutely astonishing. But we're closer to home tonight, Keith. Yeah. And we're talking about the moon. We're talking about a lunar eclipse. So I've mentioned a few little snippets so far. I've mentioned the moon is going to enter Earth's shadow. But I've also said this first hour, even though the eclipse has started, we can see here through the live feed, I can't notice any difference at the moment. But then we've got these other phases. Well, what actually happens to the moon during a lunar eclipse? And call the studio to call up any of these graphics that you'd like.
Sure. Well, I think to understand what happens during lunar eclipses, we have to look at the major players. First of which is the sun. And the sun is in the center, it's out there in space, and it's always radiating light. And the Earth is on the same plane as the sun. We call it the ecliptic plane. So the Earth is always having one half that's illumined, and the other half is always in darkness. So the Earth is always casting a shadow. The third player is the moon. And in order for an eclipse condition to exist, the moon has to pass through that shadow. It has to be on roughly the same plane as the moon, as the sun and the Earth. So that's, eclipse 101, that's about as simple as it gets. The Earth casts two types. Here we go. The Earth casts 2 types of shadows. This very large outer shadow, which we call the penumbra, and this very dark shadow in the center that we call the umbra. It's the same Latin root word that we think of for umbrella. So it means to cover or envelop. And that's exactly what's happening. The moon is making its way from the, its outer region into the penumbra, which is when we get that very faint shadow. If we see anything at all, I can think of the last time sitting out for a penumbral eclipse here, I saw nothing. So, but hopefully,
I think it's quite interesting because visually, I've never really been able to spot this very light shadowing, during this penumbral phase, this first hour, which we're kind of 20 minutes into already. But I have seen it in our images. And this is because, you snap one image and then snap another image 10 minutes later, and it's a lot easier to compare, and there's not the noise, your light adaptation, your dark adaptation with your eyes isn't affected by the images. The camera stays the same, the telescope stays the same. So we've got these 2 different shadows that's going into penumbra and umbra. So if an eclipse occurs when the Earth is between the moon and the sun, why don't we get an eclipse every month when it's a full moon? Because this eclipse can only occur, a lunar eclipse can only occur at a full moon. So it goes into that position every month, Keith. So why don't we see a lunar eclipse every month?
Yeah, well, that's what we would think, but we also know that does not happen. And there's a reason for that. The moon is not on the same plane as the Earth and the sun, as the ecliptic plane. It's actually tilted. And I know Leah has a great graph that shows that it's inclined at an angle of about 5 degrees. So Leah, why don't we pull that up? That was the animation. It's a great, great visual.
It is. A picture paints 1,000 words, and an animation paints a million, probably.
Yeah, and it's only when the moon is in this. So we're going to see it coming around here, and we're going to get the illusion that this is what we would expect from an overall view. But all it has to do is pass through that shadow once a month, and we should be okay. But it isn't, and it's going to show the 5-degree tilt. So this is the reason why the moon is always above or below the shadow cast by the Earth. The shadow of the Earth is always there. The moon isn't always properly placed. So as we watch, it's going to meet this condition right here. And we have the eclipse condition. The eclipse can take place. The interesting thing is, it's not just this month that we have an eclipse. It won't be 2 months from now. There's actually a 6-month cycle when the eclipses can actually occur. So we know that the next lunar and solar eclipse will be about 6 months from today. We just had the solar eclipse. Usually when we have a lunar eclipse, it's preceded by a solar eclipse, because we're more or less in that line, and that's what happens. So
yeah, so that tilt is just right for a solar eclipse when the moon is between the Earth and the sun, and then vice versa for the lunar eclipse.
Yes, they come in pairs, and not only that, there is an eclipse season, which is longer than the orbit of the Earth, orbit of the moon around the Earth. The eclipse season lasts about 35 days. So you could conceivably have a solar eclipse, then have a lunar eclipse, and some type of solar eclipse within that eclipse season. So you can have 3. We're having 2. And we'll have another 2 probably in about 6 months. I think the end of October, early November.
Yeah, so the solar eclipse, which is associated with this lunar eclipse, actually occurred 2 weeks ago, didn't it? But it was only a partial eclipse, and sometimes we get partial lunar eclipses. In fact, we went for quite a long time without having a total lunar eclipse. So presumably, Keith, when we're looking at this tilt and when the moon enters the shadow, sometimes it can just graze that larger penumbral shadow, but other times, like tonight, it can enter the umbral shadow and we get a total lunar eclipse. Is that right? So there's kind
exactly
of
correct.
Some gray area.
Not only that, how well the moon is placed in these shadows will determine if we even have an eclipse. If we do, what kind it will be, penumbral or umbral, or how long it'll be. So this time the moon is so well placed that they're actually calling it a central lunar eclipse. Maximum total eclipse time that you can get in the umbra, I think, is 100 minutes. We're getting 89 minutes. So very nice, long, casual night to see this if you have.
It is, and that's why I love lunar eclipses. They're such a relaxed event. You have time to take stuff in. We're going to go revisit a lot of these things that we're talking about through the course of the entire star party. But we can see in this diagram here, and we've got an even better example of this. We're talking about a blood moon, the red rose.
The blood moon.
Why does the moon turn red during a total lunar eclipse? It's going into Earth's shadow. So shouldn't it just disappear altogether?
We would think it would, but it's still, even though it's in the shadow, it still is reflecting light. And the rays of light coming from the sun get diffracted. So the shorter wavelengths of light, the cool end of the spectrum, blue, indigo, violet, are getting cast off into space.
This is a great animation showing this.
Okay, yeah. So the blue, indigo, violet gets diffracted sort of away from the moon, and it allows the atmosphere, the Earth's atmosphere, allows the red and orange to pass through, and that's what gets reflected off the face of the moon. And atmospheric conditions also have an effect as to the color that we see on the moon. So if, for example, you live in an area where there's a volcanic eruption or the wildfires out west, these can have an effect in the color of the moon. We know that in some areas they will take on a very, very dark red, almost a blackish type of reddish haze, depending on the atmospheric conditions. It's the same thing that happens when we have a sunset or a sunrise. Those reddish, reddish ends of the spectrum passing through the Earth's atmosphere. So yeah, it's the atmosphere concentrating at this end of the spectrum and casting that onto the moon.
Excellent. So the light, the Earth's atmosphere is literally bending the light,
Yeah,
around and hitting the moon. So, okay, so we are going to be, and none of this is binary. So we're going to see this effect come on quite gradually. So in about 30 minutes time, we're going to start seeing a bite taken out of the moon, but we're not going to see color at that point. So it's going to be really interesting tonight, Keith, to see when during the partial phase we start to see some color, and it's going to be interesting to see when viewers say, hey, listen, I can start seeing some color, because a lot of eclipses, it's the same with solar eclipses. Different people see stuff at different rates, so it's also going to be interesting to see whether or not people have noticed any darkening during the penumbral phase as well. Have we got any other diagrams here, Keith, or anything else you want to tell us about lunar eclipses 101 before we move on?
Yeah, you mentioned, I think, a couple interesting things. Depending on where you are, and where you are in the Canary Islands, they're sort of on the setting of the moon stage of this eclipse, and people that have the moon more centrally located will probably have a different viewing experience, I would just imagine, as the moon is in different parts of the sky, and how we see it with respect to this atmospheric change. So yeah, it's going to be really exciting to watch. It's raining here, but the thing that's good about a lunar eclipse, it lasts so long that even if you have clouds, you might get a chance to have a break in the clouds and go out and take a peek at this great event. And I'm excited to be here, of course.
I'm very hopeful that we're going to be able to I'm going to be able to get out here. I hope the clouds clear for you, at least for a peek during the total phase. Keith, you're going to come back later for our round table discussion, and maybe we can delve into some of these things a little bit more after our viewers have actually had a chance to see the effects that we've been talking about, the bite being taken out of the moon. We can talk about that curvature as well, which I always think is a really interesting facet of a moon. When you look up at the moon, when you start seeing that bite chunk taken out of it, it's something that looks really odd, because it's not a phase of the moon, because that curvature's slightly different. But anyway, Keith, we'll talk to you a little bit later. So for the round table, thank you very much for that. Lunar Eclipse 101. Now then, coming up after this short break, we're going to delve into some eclipse mythology with Milton, who has been the author of some of Slooh's cultural quests. We can talk about the Incas and how they see these. Just imagine being an ancient without the understanding of the mechanics that Keith has just told us about. And suddenly this familiar orb in the sky turns red. How terrifying would that be? And I bet you it was terror rather than awe and wonder. So anyway, we're going to be talking to Milton right after this break. Bye. Right, we are back. Welcome back to the online telescopes lunar eclipse, our May's full flower supermoon total lunar eclipse. That's not bad, is it, for 3 a.m. in the morning? Listen, here are the timings up on the screen of what we got. Don't move it yet. So where are we now? We are in that first phase still, the penumbral eclipse. We're in that. Thank you very much, studio. We've got in 28 minutes time now. Studio or anybody else, please feel free to shout out if I miss the timing of that, because we want to see that. Bob Berman is going to be joining us for that. But at the moment, before we talk about the actual partial phase, we're going to talk about a little bit of mythology. And for that, I would like to welcome our special guest, Milton. Milton, how are you?
Hello and hi to everybody. I'm happy to see all my colleagues in Slooh. We have a large audience, very happy to, be able to communicate with so many people through this Zoom meet.
I know, it's terrific, isn't it? Now, as I said, Milton is a Slooh member, but he's also authored several of our quests, and our quests are split into different things. Some of them are scientific based, some of them are cultural based, some of them mythology, spiritual, all manner of things, historical. But Milton, to start off with, when we were talking about what we were going to cover tonight, I think it was just a couple of days ago, I was saying to you, because you're going to be talking about some of the stone monuments and how the Incas saw these eclipses. And I was saying, well, I'm just down the road from Stonehenge. I'm a few miles down the road from Stonehenge. And here we've got halfway around the world, these two civilizations, building these beautiful stone monuments to mark a lot of these events. And we were kind of querying, how far away were those two sites, and totally independently building these huge monuments to, oh look, and then we've got one. Did you find out how far away Stonehenge is?
According to Google Maps, we're more than 6,000 miles away.
Wow.
Almost double that distance in kilometers. So in a time when communication, especially in the Inca time, was done only by foot, and this is no myth. Incas communicated using a variety of knotted pieces of wool that they called quipus, and the quipus were literally transported on foot throughout the hills through an intricate network of roads that would connect the whole empire. So that was the only communication they had.
Wow. Now you write about the pantheon of gods and goddesses of the Inca. What place did the moon have in that?
Well, a very important place, actually, because what you're seeing in the picture is a door, a gate that the moon will cross only at the end of the calendar cycle for the Inca. The two carvings that we see on each side give us the impression that it's part of a bigger structure.
That's the two notches, is that?
Yeah.
Okay.
But only this part has been unearthed and put to display. The rest is still underground, and the good news about that is that it's still being preserved. But this part is already suffering some of weather erosion, and we need to protect that.
Wow. Well, so what? Why were the sun and the moon given equal importance among the Incan deities?
Well, one of the things I can show you right away behind me is what the Inca believed was the whole cosmos. Everything is centered on Cusco, okay, right behind me. Cusco is that city in the middle, surrounded by mountains, and of course, the whole universe would, work around. Up on the top, you will see the sun and the moon as equals. They had no way of knowing that the sun was so many times bigger and the moon was so many times smaller. So if you look at the skies, you will see that both of them have the same relative size. And that's why the moon can sometimes eclipse the sun.
Yeah.
So to their eyes, these two were just two equal elements in the sky. Now, the sun, represents the male, and the moon represents the female. So the moon was put up there to be, the protector of all female on Earth. The world is divided into the upper world, where these two are in the skies, the Milky Way that you can see, on one side, and of course the underworld. And this is the cycle that the Inca thought, everything followed.
Wow, I love that. And you're talking about that remarkable cosmic coincidence that we happen to be fortunate enough on Earth that the distance of the sun and the relative size of the moon and the sun are such that they appear within a whisker the same size. And that's why we get total solar eclipses. And we also then get annular solar eclipses when the moon is slightly further away in its orbit and we start seeing some of the sun behind it. But for them, it makes such sense, doesn't it, that these two celestial bodies are equal in the sky. So how then did the Inca explain eclipses? Were they harbingers of doom for the Incans, or how did they see them?
Yep, the Inca see that, as many people see it, as a bloody event. I will, of course, tell you more about that near the end of the presentation. But yes, for the Inca, the moon is bleeding. And it's a very sad episode, but something that they will overcome because of a strong belief in what they can do to solve that problem.
So could they predict eclipses? Because this is what we think of Stonehenge as basically being a huge orrery, something to predict these particular events. Usually in the case of Stonehenge, it was for solar activity, although today, if it was clear, or this morning, if you were at Stonehenge, you'd actually be seeing the moon setting behind Stonehenge in its blood red. But did they predict them?
Yeah, the fact that you have all these structures, built, always predicting the presence of either the sun or, in this case, the moon, tells us that they could. If Studio could go to image 0C, okay, this one, for example, yeah, that one. This one is a cave, for most of us, but you can see how they changed the appearance internally, because they also predicted the presence of the moon through the door of the cave into this, what is now a shrine, and dedicated exclusively to the moon. This is not too far from Cusco, and you can go and visit that together with the capital of the Inca.
It's absolutely astonishing. I mean, this is the high tech of the time, but the power that used to come for anybody who was able to foretell and forecast these celestial events. I mean, the power that gave them, because they must have been imbued, as magicians or something like that. But so did the Incans have any idea of how did they see the composition of the moon? What did they think it was?
I'd like to start by what you said, the power it gave them, because, the Inca Empire was built based on a very strong story, not so much about, war, but telling a very compelling story. So the fact that they could actually predict certain things in the sky made, the rest of the communities in the Andes region believe in this. And so that's how most of the empire expanded. In the classic time of the Inca, of course, they had acquired a very powerful army, and they were, the owners of the territory. But before that, gradually telling this story and convincing people that they were right was, their strongest point. Now, going to answer your question about the composition of this of the moon. I hope Studio can help me go to my image number 2A. There you will see what they believed the moon was made of. The moon is considered to be made of silver. And there you see, for example, how silver in its molten stage more or less looks like a full moon.
Yeah, it has the dark and light areas. Yeah.
Yes, they knew that, and they, of course, said that this was the composition of the moon, and all the palaces, all the buildings dedicated to the moon were actually, decorated using silver, laminates, something like our aluminum foil, for example.
Okay.
They would completely, cover the walls and things around with this. In the next picture, I show you some of the elements of decoration that they would make with silver and with other precious stones. This was, for example, for them, the image of the moon, right?
Well, so what age is this, Milton? When are we talking?
We're talking about anywhere between 600 to 800 before this our time, when they had acquired the classic stage, as we call it, because pre-classic were basically very rudimentary buildings, stone, etc. But when they started looking at the beauty of things was in their classical period. In picture 2C, the next one, you will see actually the representation of the moon as the goddess that would protect all women, right? But it's not a very happy story. This goddess is always crying, and what she's crying are silver teardrops. Mm-hmm. These teardrops will accumulate, drop by drop, and that's the way they explain the phases of the moon. So, for example, right now, the kiln is full of these tears. And as time goes in the next few days, you will see how all that silver is poured into the mountains where they found the silver in this world.
Oh, those are wonderful. I love that. Absolutely love that.
Yes, I'm glad that John Bouvier is here because, together, John and I put together this story in one of our quests. And John made an incredible, way of looking at the moon as it appears in the southern hemisphere. And you can actually virtually see how this worked over there. It's, a fascinating story that tries to explain, at least in part, how we got silver on Earth and why the moon has those colors.
So we've got a question there from Michelle Sturgis. She's saying, what's the name of this goddess? Does she have a name?
The name in their native language is Quilla, and since she was the mother protector of all females, they would call her Mama Quilla, K-I-L-L-A.
And that's reflected, isn't it, in the name of the quest?
Oh, yeah, that's true. The name of the quest is the Inca moon, or Mama Quilla.
Okay, excellent. One last question. Did they have any explanation for, so they're thinking of the moon as being made of silver. Did they have any explanation for the patchy surface, the dark areas, the light areas?
Oh, for sure. Let me first introduce you to one interesting character in image 1A. Studio, please. I particularly chose this image to show you that, there is a very interesting character in Inca mythology represented by the fox. They called him Atok, okay? And just like our fox, Atok is very intelligent, extremely intelligent, very witty, very cunning. And so it turns out that this fox in particular fell in love with the moon, okay? Yeah, and so he wanted to reach up there and express all her love. Behind the fox, you see the antenna of the ALMA, the large millimeter array in Atacama Desert in Chile. So as you can see, this fauna was present in the area. And Atok fell completely in love, head over heels for the moon. The next picture shows Atok looking at the moon and wanting to be up there, express his love. The moon, of course, was a goddess. She will not accept him very easily. But, persistence and time made its way. And finally, Atok reached up and was together with the moon. The moon by then had accepted the courtship and decided to embrace her lover so tightly that the next picture will show you what happened. This is a picture I took just last night, showing you a very close approach of the moon and the blotches. Now, if you see the upper left corner, you will see the profile of Atok.
Yes.
Right across from what Bob Berman once told us was the woman on the moon. Well, that's Atok, and the moon embraced her lover so tightly that actually killed him.
Oh no!
And the blotches that you see in the moon are precisely remnants of the poor Atok's body that stain the otherwise, pristine dress of the moon.
So many of these stories, Milton, are kind of so sad. They bring a tear to your eye, but you tell them so beautifully. And I hope we're going to hear far more of them, both on the member star parties that you turn up to, more quests, because I know you're working on more quests, but also in our round table a little bit later. I think we should talk a little bit more about some of this mythology, but thank you so much for
and I'm sorry the stories are kind of sad, but if you walk the Andes Mountains, you will always perceive that degree of sadness. The music they used to play is always very sad in tunes, but their stories are beautiful. It's a very nice culture to explore, and I'm very thankful to Slooh and everybody for supporting my work, and of course, helping me tell this to the rest of the world.
Well, you're a great contributor to the community, and we greatly value it, Milton. Thank you very much. Now then, studio, we need to be getting a shifty on, I think, because we are about 10. Oh, look at that, you see. Now, okay, we can ask some questions, can't we, of people? But I can definitely see. So don't forget, going back to the beginning where we talk about the penumbral phase, this first phase, this first hour, not really very much happens that's obvious. But am I the only one who can see this? I can see quite a fair old whack of darkening there. And we are still 10 minutes away, 11 minutes away from the official start of the partial phase of this lunar eclipse. So this particular image stream, this is from, it looks like our Canary 1.5 meter telescope. And this is one of the telescopes that Slooh members control every night. Don't normally use it for the moon because the moon's actually incredibly bright for these telescopes, and the telescopes are designed to capture as much light as possible. Loads of people thanking Milton. So don't forget, Slooh members, you can join the webinar. There's instructions on the Star Party page. You can come in and you can interact with everybody. When we do our round table, you can join that conversation as well. Now then, we are not going to take a little break as planned because we are running a little bit behind. So I would actually like to welcome Gretchen. Gretchen Bickert is joining us. Now, first of all, Gretchen, you're a Slooh ambassador, and you've got a front row seat for this because I can see blue sky behind you. Where are you and what are you doing there?
I am in Portal, Arizona.
Okay.
And this is very close to a place called Sky Village. It's a place where a lot of people come because they have massively dark skies. Well, it's not dark quite yet because it's still light. But I ran outside a few ago, and the moon is coming up from behind the mountain. But it has been super hazy. So we've been to try and blow the clouds away. It's not working just yet, but we're hoping. But as soon as it rises above that layer of clouds, we are sure to have a fantastic view, and I hope to send over some pictures.
Some images. That's going to appear in the mobile 3 slot. So for members who are watching on the Star Party page, we've got all of our live feeds there. You can snap images. So if I were you, I would snap an image of this. At the moment, which is what we're saying. So it is the Canary 1/2 meter telescope. In fact, now, if you don't mind, Gretchen, it might be a good idea just to pop through some of these feeds because we haven't had a look at those. Studio, we should be keeping some of these feeds up a little bit more if possible. Let's hop over to Canary 2. So did that change? Yeah, did. Okay, so we are seeing quite a defined darkening there. Let's have a look at Canary 3. When we started off the star party, I said to everybody, don't worry, that is black. It is actually black. I said to everybody, this is going to be the telescope to keep an eye on, but it's a bit of an experiment, all right? Because this particular telescope gets totally overwhelmed with the bright light of the full moon, which is basically what it is at the moment. And that's what happens to the images. And then if we stayed there, it's a really, really white, just whited out moon would appear. But over the next hour, that's when this feed comes into its own, because this is where we're going to see all of that delicious color coming in. Let's have a quick look at the Chile telescope as well, please, studio. Chile 1 wide field doesn't give us a full view, but actually we can see that same shadowing occurring from the left as well. So all of these orientated in the same way. Let's have a quick look at the Canary all sky camera, check on conditions. What have we got? There it is. You can see here, you see the moon. A local time in the Canary Islands is 3 a.m. and we can see that the moon is going over to the right hand side, which actually is to the west. So in the Canary Islands, it's kind of hovering just above the horizon at the end of the total phase, but that's why we've got some other feeds as well. But anyway, back to Gretchen. So we've learned about the mechanics of lunar eclipses and how they were seen by the ancients, but some of these celestial phenomena can profoundly affect some people, including me. I've been fortunate enough to travel the world to bring these live events to the public, and every single total solar eclipse has brought me to tears. I mean, I'm at an absolute standstill. Gretchen, we've talked a lot about this because, you know, I think you call it woo, don't you? But
I call it woo.
You call it woo. What is it that, why do some of these celestial events affect some of us so deeply?
Well, you know, Paul, I'm so glad that you are talking about this, because this is really my world. I like to, it's the science and woo. You know, you mix those together and then you add Milton's magic. We've created a new saying, Milton's magic. And
That's
we're
good.
now,
I like that.
right? So, but we have like the whole picture, and that's it. It's the big picture. It's cosmic. You know, it's like, I have this shirt on. Of course, it says tacos because I'm in Arizona, but it's really like all these different ways people's beliefs blending together, and we're all hanging out and we're having tacos, right? And that's like what the eclipses are. The eclipses are really this opportunity for everybody to get together and be able to just enjoy this cosmic experience. You know, it's like the sun shines on everybody, not just me, not just you, but everyone. And that's the same with the moon. So these events, in fact, I'm visiting friends down here in Portal, Arizona. And so we're all getting together because of the eclipse.
Because of this,
right? We're all hanging out because of the eclipse. So on just a very basic level, it creates connection. It creates this common thing that we all love. It's a sense of awe, even though Keith so magically, magic's my word of the night, so magically explained the science behind it. They're still like, really? How is this happening?
Yeah.
Oh my God. And so I think that is what really is part of that spiritual awe.
And I think we'll talk about this later in the round table when we all get together, because I'm interested to hear other people's experiences of this. And for me, I don't live a life of woo, as you know, but these events, to me, I've tried to work out what it is and why they affect me. And a lot of it is this sense of almost bewilderment, because what I'm seeing is so unfamiliar. And, you know, we go back to this and we're looking up at the moon. Unfortunately, a lot of people kind of take the moon a bit for granted. They don't look up at it. So actually a lunar eclipse is great because it gives us the opportunity to say, hey, listen, you've got to look at this tonight. But what we're seeing now, if somebody looks up at that moon, look like we're seeing in the live feed, they think, oh, it's a a crescent moon, or it's a gibbous moon. But something's not right about it. The curve that's being taken out of it isn't what I'm used to seeing. And you don't necessarily know what it is. And it's the same with solar eclipses. All of these different phenomena in a solar eclipse, your brain is almost in overload, or mine is, at a primordial level, saying something's going on here, but I don't know what it is. And we witnessed this at Nashville Zoo, and the animals did it. Do you think there's part of these experiences are so alien to us that it's kind of setting off some primordial stuff as well?
Oh my gosh, exactly. Because now it was interesting when you were at Nashville Zoo with Jim, because I worked.
Oh, of course, you worked there, didn't you? Yeah.
Well, not at Nashville, but I worked with Jim at the Columbus Zoo. So I was in the zoo field for like over 20 years, and it always affected the animals. These events, in fact, animals are so tuned in to our natural world, even more so than we are. And so the birds, it's very interesting, this sense of quiet and what's happening to the sun, and everything is a bit wonky, right, when that happens. And so I think that when we talk about the lunar eclipses, the solar eclipses, it's really this really great opportunity to be tuned back in, to remember, to take this time to reflect. And it's very symbolic because of this reflection, the moon, reflecting the light, the sun. And so it's that time to go within and also reflect. And I love what you said earlier too about the solar eclipse versus the lunar eclipse. Solar eclipse to me is like pow, bam, fire, energetic. But the lunar eclipse is like long and leisurely and lovely, and it's La Luna, and it feels very nurturing to me. So while it's emotional, I start to think about my life and what changes I may want to make. I feel like I have La Luna just like hugging me. It's like this cosmic hug.
And when you start bringing in stories like Milton's that layer over these feelings as well, I was just looking, this is a live image from the Institute of Astrophysics at the Canary Islands. Some of those guys there run skylive.tv, and just a live video coming through. I mean, it's just, I love that. And you start layering Milton's storytelling over that, and it gives me a whole new view, literally, when I'm looking at that. So what are you looking forward to most this evening then, Gretchen? I mean, you've got loads of people around, and I hope lots of other people have the opportunity of doing that, just getting together with neighbors and stuff like that. If you think other people don't know about this, and you're living somewhere where you can see the eclipse, and you haven't got clouds like I have here in the UK, what will you all do later on? Will you sit around and just drink and take in the beautiful sight of this moon turning red?
Well, yeah, it's for sure like a big celebration. As you know, I'm very much into music. And
are you going to be playing music and drums?
Yeah,
and
I brought my
stuff?
gongs,
Cool.
and I have some Tibetan bowls and chimes. And so it's just like this magical sort of spiritual jazz fusion, right? And, perfect for a lunar eclipse kind of music.
Excellent.
So, right, see, Milton, I got a thumbs up. So, intertwining that and just like this ability to connect and have fun and be with, a few other people, and being on Slooh with, the community, to me is just, I feel so grateful that I'm with this humongous group of people who love the same thing.
And we're kind of doing this, we're doing this kind of thing every night. We've got our Discord server, members are chatting there while we're watching all of the live streams from all of Slooh's telescopes. We're not just here for these, one-off events. I say one-off events, you know what I mean. But we're doing this every single night. So this is going to be studio, by the way, probably one of the best feeds to stick on, because we're going to start. I want people in Zoom chat, Slooh members who have joined us. I want people to start saying when they think they can start seeing some color in this. But Gretchen, you're going to hang around. You're going to come and join us, aren't you, for the roundtable?
Absolutely.
I would love to hear more about what you're doing, the kind of views you're getting down there. And let's talk as well. You know, it'll be interesting to hear what everybody says about how some of these events have affected them.
Oh God, yeah. I totally would love to hear, like, do they have any shifts? Do they spend it meditating? Do they party? Do they crack a bottle of champagne? I mean, what do they do? Share.
Cut into your, you know, not celebrations, but, you know, your whole woo thing, you know. So thanks for cutting into your woo time.
Thanks, Paul. I'm glad to be here.
Right, let's keep an eye on these wonderful images. And we are now, of course, we've transitioned officially, not that you'd know it, because as we're saying, you know, this is a slow, leisurely paced celestial event, but we have transitioned officially to the partial eclipse phase. That happened about 3 minutes ago. But anyway, what I would like to do now is we're not going to take a break, by the way, studio. We're going to go straight in. Oh, look at this. This is another feed from the Canary Islands. This is on top of volcanoes. What is it? It's 2,000 meters high, 8,000 feet above the Atlantic Ocean in the Canary Islands. That's where Slooh's telescopes are based. The largest optical telescope in the world is based there as well. So you're in good company, and anybody can control those telescopes to look at anything in the night sky. Can't quite see that new black hole, not a new black hole, but you know, the news that was there. But anyway, I would like to move us on now, because I want to bring in one of our most popular guests of all time. He's an astronomy author. One of his most recent books is Zoom, would you believe? Very appropriate. But he also writes the Strange Universe column for Astronomy magazine. It's Bob Berman. Bob, hi, how are you?
Hi, good to be here. Nice to see you, Paul.
Well, we haven't seen you for so long because we haven't done a public star party for so long. What do you think of some of the live views, Bob, that we're seeing already? They're pretty cool, aren't they?
Oh, it's very cool, especially for the likes of you and me, who were living in a very rural area in a little town of 140 people, and skies are nice and dark, but overcast tonight. So it's so great to have these other telescopes scattered around the world to let us still see this event.
I thought I had actually assumed that you were going to get some good weather tonight, Bob. That's a shame that you're not going to be able to pop out, because we're keeping you up late. Would you stay up late anyway to see a lunar eclipse now, because you must have witnessed quite a large number of these? You're normally doing, you know, outreach events and visits with other people. You know, would you stay up for something like this?
Oh yes, certainly, and most people have, because unlike a solar eclipse, which, as you know, a total solar eclipse occurs only once every 360 years for any given place on Earth. But a lunar eclipse is visible for everybody on Earth who has the moon in the sky at that time. So just about everybody we know has seen at least one in their lifetime. So much more common. And we've spoken of the difference between lunar and solar. One of the things is that when totality happens, with the solar totality, as you well know, all sorts of bizarre phenomena occur that are life-changing and make people weep, that are emotional. With a lunar eclipse, absolutely nothing happens at totality, except the moon, which has already started to turn coppery red, is now fully coppery red. So it's a very, very different event.
It is, and I do enjoy the leisurely pace of one of these. So, Bob, first of all, I know you've been listening to a little bit of this, but the phenomena of a lunar eclipse, passing into these two shadows, we did start seeing a little bit of darkening during that penumbral phase, but you know, we were recommending people to actually join the show now, you know, because this is when the real action starts. Take us through what happens during a total lunar eclipse.
Yes, we're seeing it's really a wonderland of shadows of different curvatures, shadows and non-shadows, circles of different curvatures. You can see that the dark bite at the top of the moon that's being taken out of the moon, which is Earth's shadow. Now, our shadow tapers like a chopstick. It gets smaller and smaller until when it reaches the moon's distance of about 250,000 miles, it's about half the size it starts out at. Nonetheless, half of Earth's size is still double the moon's size. And so we're looking at things that were realized by the likes of Aristarchus of Samos, probably the most brilliant early astronomer, about 300 BC, who looked at this same thing and noticed that there's the curve on the top of a shadow, has to be Earth's shadow, because the moon is exactly opposite the sun in the sky at this moment, precisely opposite the sun, which is where our shadow has to be. And so if that's our shadow, we're round, proves that we're round. This is proof that we're not on a flat Earth.
The flat earthers won't like that.
Yep. And secondly, the size of that curve shows that it's larger than the moon. He was able to figure out the size of the Earth, the distance from the Earth to the moon, the distance from the Earth to the sun, and all sorts of things, looking at what we are looking at. So I see a history lesson here that we can all pick up on without opening a page of a history book. We're seeing our own shadow. We're seeing that it's much larger in circumference. The shadow's size is certainly bigger than that moon's curvature, showing that we live on a much larger object than the moon. And finally, it doesn't look like a normal phase. You know, people sometimes say lunar eclipse, the moon goes through all these strange phases, but we all know what the phases of a moon look like. Sometimes it's a crescent, sometimes it's gibbous, but look at this, what we're looking at. Does that look like any phase that the moon ever naturally shows? Absolutely not. And it gets to its absolute weirdest at about 11:15 Eastern time, 11:20, when there'll only be a little spot of sun hitting the moon. And that's when the phase, in my opinion, reaches its absolute total weirdest. So if you wanted to frighten your children, get them out of bed, point them up at the moon at that time, and they'll probably need psychiatric care for their lives.
I love that moment, you know, in the moments before the total phase, because I was looking back at some previous lunar eclipses that we'd done, Bob, and I think it was one in 2018 or 19, and it was reminiscent to me of the diamond ring that we see during a solar eclipse. There was this beautiful peachy colored moon, but just one tiny sliver of, you know, going back to Milton's story, bright, brilliant silver, almost sparkling right on the edge of the moon. Do you see that on all lunar eclipses? You know, how can we forecast a lunar eclipse? Do we know that they're all the same? Is this one going to be slightly different to the others that you've seen?
Oh yeah, they tend to be similar. Now, back when Mount Pinatubo in the Philippines erupted, going back about 40 years ago, it threw so much ash into our atmosphere that instead of our planet Earth throwing a red shadow in space the way we normally do, we cast a black shadow for that eclipse. And the black bite taken out of the moon that we're looking at right now remained black as it got bigger and bigger and bigger. It never turned red.
Wow.
So it's kind of giving us a report card about our own conditions. This is the only celestial event where we look at another body in space, another celestial body, and get a report about ourselves, about our own conditions.
There's actually a telescope dedicated to Earthshine, about 200 meters away from the Slooh telescopes in the Canary Islands. And what this telescope does, Bob, is it measures the condition of the atmosphere by observing the moon, its brightness, and the Earthshine that we get as well. It's a fascinating instrument. But going back to this, it looks very alien, doesn't it? Because it's very obviously not like a normal lunar phase, that, as you say, the curvature is very different. At what stage would you expect us to start seeing some color appear here?
Oh, usually when you start approaching about half of the moon being darkened, you can start picking up on that coppery hue.
Yeah.
That recent term of blood moon, which somebody concocted only a few decades ago, there are astronomers like Fred Espenak, who has calculated the paths of solar eclipses now for decades that all of us use to know exactly where to go to be within the path of totality. He hates the term blood moon, and I'm not too far behind him, because
I'm the same, actually.
it doesn't really look like blood. It's more like a penny. It's a coppery, orangey color, but let's let all of our Slooh viewers judge that for themselves. And but yes, we'll start seeing that color a little bit. I mean, it starts out being black. Remember, part of it is your own eye, because we're looking at a very bright object. The moon, even though it's 450,000 times less bright than the sun, it's still bright enough that our retinas and our eyes and our sense of vision, our cone-shaped cells, we have 6 million of them, are set to give us a proper exposure for the moon. And that means we're going to underexpose the dark part. So the dark part of the moon is going to look darker than it should, but they'll reach a point when the moon gets small enough and we don't get that overexposure from it as much. Plus the dark part gets a little bit more prominent, and that's when the red comes in. The red's there now, but we can't see it yet.
The other part of this, Bob, which I think is made it more difficult to compare lunar eclipses, is the kind of setup that people use. When we're all watching visually, most people's color perception is kind of roughly the same. But with telescopes and cameras, so much depends on just something so basic like the white balance level that's set on the camera. And then you see these other photographs of lunar eclipses and somebody's boosted the saturation artificially. And I don't think that really helps to really convey the message. And I think that's why I agree with you. I've never really thought of these total lunar eclipses as being a blood color. I think the most I ever saw was kind of hinting on a crimson. But to me, it's always more coppery, as you say, or peachy is the one that I've often seen. So it's going to be interesting to see what we get, because different cameras tonight, different video cameras, different CCD cameras, will all give us a slightly different view.
You're right. Plus, this is one of those events. It's interesting, isn't it, that arguably the most spectacular celestial events require no optical aid. Yeah. Now, we're glad we have Slooh, because places that are overcast, like where I am and where you are, we wouldn't be seeing this without Slooh. But you don't need a telescope or binoculars to get the full impact of a lunar eclipse or a solar eclipse or the aurora borealis, which is another one of the top 5 spectacular events, or a great meteor shower, or for that matter, a great comet, although binoculars do help with that. So what I'm saying is that the most awe-inspiring, almost spiritual celestial events don't require modern technology, and they don't require cameras or telescopes or anything. And the same is true of what we're seeing tonight, although I'm glad we've got Slooh, otherwise we wouldn't see it at all.
Exactly. Now, so you touched on something then, Bob, that we've already talked about, and you raised it as well, this emotional and spiritual feeling and awareness that some of these celestial events can give. You have traveled the world, taking tours for the Northern Lights, for solar eclipses. Have you, over your period of time doing those events, managed to pin down what it is that, is affecting people so deeply with some of these events?
No, actually, I don't know. It's a different realm. Just as there are things in life that I think all of us experience that we recognize to be different from the intellectual, different from logic, different from science. Science teaches us how to build jet planes, the science of aeronautical engineering, or construct bridges and things like that. But how does science help us when we fall in love? And, you know, it has nothing to do with it. Love is outside of science, and we know that. So there are objects of amazing beauty. We know that using a telescope, especially the Slooh telescopes, the rings of Saturn and globular clusters, and there are some other objects that take the breath away. And if you were asked to explain why is it so beautiful, boy, I'd be at a loss for words. Why should a bunch of white dots against a black background, which is a globular cluster, why should that make people gasp? What is it about Saturn with those rings? I mean, Galileo thought they just looked like the handles of a teacup. What's so special? The star Albireo, a beautiful colored double star. Everyone hearing my voice who's ever had a telescope knows what I'm talking about. Here's a star that looks like a single star in the constellation of Cygnus, that through a telescope shows itself as two stars. One is gold and one is blue, but they're pastel colors. It's a pastel subtle blue, and it's a pastel subtle yellow color. Nature provides much more saturated colors elsewhere in every sunset, for example. Why do we find Albireo so inspiring? So I think, Paul, these are mysterious, that we're so swept away to the point that a total eclipse totality makes people weep. What is it about it that does that? I can't answer that.
I'm fascinated, and we've actually had a psychologist join us on some of our solar eclipse events, and she's been working for over 10 years now and has written multiple papers and also a book she's interviewed hundreds and hundreds of people who have witnessed totality, solar eclipse totality, and she hasn't got to the bottom of it either. But Bob, another thing that hasn't been mentioned very much about tonight's full moon is that it's also a supermoon, something else which is a little bit contentious. So we've got the blood moon label being a little bit contentious, dislike from you, and I'm the same on that one. But supermoon, can you explain to us what a supermoon is? So tonight is the first of 3 consecutive supermoons. What does a supermoon consist of?
Sure. As the moon goes around Earth, its orbit around us is not circular but elliptical, which means it's closer to us at certain points in its orbit and farther in other points. And if that orbit just was stationary, then we might be able to say in the middle of each month the moon comes close. But the orbit itself goes around us. Isn't that crazy? It's not just the moon that orbits us, its orbit orbits us. How can an orbit orbit? One way of thinking of that flat plane of the orbit changing its orientation in space is if you dropped a dinner plate on the floor, if it managed not to break, it might rattle around like this for a while, changing its orientation. And the moon does that every 18.61 years. And that means that when it gets to the place where it crosses its nodes, where there'll be an eclipse, those are occurring a little sooner than once every lunar month. The same thing with its distance. So its distance, that is from its nearest point, perigee, to the next nearest point to Earth, perigee, is not the period of moon going around Earth, which is 27.32166 days, but a little longer than that. It's 27.55455 days. Easy to remember these figures because look at it, Paul, 27.55455. You can't forget that. It's easy.
You always say that, but I'm dreadful with numbers, and I don't even know my own phone number, Bob. So no, not so easy to remember for all of us.
So once a month, the moon has to come to the closest point in its orbit for that month. And in the old days, we would say, well, this is the night of lunar perigee, its closest point to Earth. It's often only a matter of a few miles or a few hundred miles different from the night before, the night after, or 2 nights before. You certainly won't see the difference. It'll look exactly to the eye like any other full moon or any other moon of that phase. Someone, again, here, we just wanted to hype it a little bit, calling it a super moon. Now, why are some people, you mentioned that it's contentious? Well, because we're used to the word super, at least in the United States, as denoting something extra special, like the Super Bowl or a supermodel, or, you know what I mean. So if the moon doesn't look any different, in what sense is it super? Well, it's the closest moon of this month, and the next month will also have a point where it's the closest. There was a time when we would only call supermoons the single night when the moon was closest of the entire year.
And that's what I think we should be going back to, because I think this 3 consecutive moons, how can it be super if it happens 3 months in a row?
I agree.
But what I do love about supermoon is that it does get on the news, and it encourages people to go outside and actually lay their eyes on the moon, which actually I think a lot of people totally neglect. Even a lot of astronomers neglect it to capture images of. But look at it now, Bob, in this live stream. So one of the interesting things here is if they increase the exposure, the sensitivity of that video camera at the moment, so that the illuminated part is probably totally white. I suspect we might start seeing some color in that darkened region, but we can see now, just as we're talking, how much the moon is moving into Earth's umbral shadow. And you can see that curvature that we're talking about. Very, very different, isn't it, from a crescent, the normal crescent curve that we see.
Right. And it also shows you its speed, because the moon is the only known object in the universe that moves its own diameter per hour. It moves its own width in an hour. Its moon happens to be 2,180 miles in diameter, and it moves 2,200 and about 40 miles per hour. That's almost the same number. So it means we would expect the moon to displace its width, move its width in an hour, and we're seeing that right before our eyes. This the first touching of the dark part of Earth's shadow, the umbral shadow, occurred at 10:28. It was, if you round it to the nearest minute, and it'll be fully in at 11:29. So it's an hour and a minute. So it just shows that the moon is moving its own width per hour, which is kind of a cool fact, considering no other body that's known in the universe does that.
So, Bob, I started off by introducing you and saying that you pen the Strange Universe column in Astronomy magazine, which is always my first page that I turn to. I've told you that before, and it's absolutely true. How many years have you been writing Strange Universe now?
Well, yeah, for Astronomy magazine, I think since the late 80s. For a number of years, I was still writing the Night Watchman column in Discover magazine, which I did for 17 years. And then, as if that wasn't enough, I was, and I still am, the astronomy editor of the Old Farmer's Almanac. That really has the biggest circulation of all. So I'm really responsible for all three. Now, in the Farmer's Almanac, I can do something about this supermoon, blood moon, hyped up astronomy thing. You mentioned a few moments ago that the one good thing about calling it a supermoon was maybe it'll get people out to look at the moon, and when they wouldn't normally go out, because the word super will attract them. My fear is just the opposite, that they will go out, they'll look at it, and they'll say, well, that doesn't look any bigger than any other full moon, and they'll be disappointed. They'll either think the publication got it wrong, or they'll think there's something wrong with them, that they can't see the huge moon that they're expecting to see. And disappointment is never a good thing. So I'm always a little worried that when you hype something and people are disappointed by what they see that we're not doing any favors for astronomy. So that's my fear.
Yeah, I think there's a fine line, isn't there? Oh, now studio, tell us, whose feed is this coming in?
This is John's feed from Omaha, Nebraska.
Wow, thank you, John. That's brilliant. Oh, look, we can see the shimmering. That looks like it's probably quite low on horizon still, maybe, because we can see the shimmering of the atmosphere in this live feed. Bob,
A little Parmesan color.
Unlike the Terminator that we normally see, this shadow it's a bit blurry, isn't it?
Yes, it is. And you're right. The Terminator, for those of you who are new to astronomy and remember the Arnold Schwarzenegger movies, the Terminator is the little line separating day from night. And because that's where the sun is shining at its lowest angle, it lights up all the craters and mountains and lunar features optimally, because the light's coming from the side instead of shining straight down like a flash camera. So all the goodies, all the detail, all the fine stuff that you want to see lies very close to the Terminator. So experienced astronomers, or even beginners who love the moon, and then even after 50 years, I'm one of those, I'll watch the moon almost every night around the first quarter moon when the Terminator is right there running down the middle of it. That's when you see all the details. But here we have a Terminator imposter. It looks like a day-night shadow line, and in a way it is, because on one side of that the sun is shining almost fully, not quite fully, because on the bright side, if you were standing there on the moon, you'd actually see the sun slightly blocked off by a piece of the Earth. Nonetheless, on the dark side of that shadow line, no sunlight is hitting it at all. And you're right. So we're getting a blurrier line. And one of the reasons for that is that the edge of Earth is not sharp as when it's projected into space. We've got clouds, we've got a thick atmosphere, and we've got 250,000 miles that this is being projected. So the final outcome is not a razor sharp line. I
think that's a fascinating feat. So this is Slooh member John Larson, Omaha, Nebraska. So this is looking great. And I bet you if John, blew up the exposure time and sensitivity of his camera, which would totally, saturate the right-hand side, we might start seeing some color in here. So Bob, we were talking about strange universe. We've got a couple of minutes left. What's the strangest thing that you can tell us about a lunar eclipse, or indeed a full moon?
Oh my goodness. My favorite fact about a full moon is the way our eyes change their perception of light and darkness. Now, I know you know, but most people still don't realize what Einstein and many others did, which is that we never see the actual external universe. We always just see the inside of our brains. The reason for that is that light, as I know many of our listeners and observers are aware, is an electromagnetic phenomenon. That is a magnetic pulse at right angles to an electrical pulse. Now, we can't see electricity, we can't see magnetic fields. So by itself, photons of light, bits of light, have no color, have no brightness of any sort. What they do, though, is they carry the electromagnetic force. They're like butlers. They are force-carrying particles for one of the four forces in the universe, the electromagnetic force. So they deliver it. And when it goes into our eyes through a retinal cell, it delivers it like a butler. And the result is a little bit of electricity that gets released into our retinas. And that gets carried up heavy-duty cables into the back of our brains, where tens of billions of cells are dedicated to doing something with those electrical signals. And what it does is create visual images, including colors. So everything we see, including the image on our screens right now, is actually being created and being perceived every physiology book will tell you this, inside the brain. We're not looking at the external world. We are looking at the inside of our brains. Now, this is amazing stuff.
A great way of thinking about it.
Even Isaac Newton knew this. He wrote specifically, he said, the rays are not colored. He knew that at a sunset, up till then, people thought that there were colored red rays coming into our eyes. And he said, no, the rays are not colored. He knew that we're creating the colors in our minds, in our brains. And so that's what's happening here. Now, the images that we're creating on the screen will all be due to how much light, how much darkness, how our retinas and our brains compensate for the amount of brightness and darkness. And when it gets to the right amount, we'll be able to see color.
Great. Bob, you are going to join us again in half an hour's time to mark the beginning of the total eclipse. So
Okay.
hopefully by the time you come back, we are going to see a beautiful coppery, peachy, reddish, whatever color it turns out to be, moon. But thank you very much, Bob, for now.
My pleasure.
Now, after this short break, we are going to be joined by the Online Telescope's Director of Curriculum, Dr. John Bovair, and John is going to be telling us about Slooh's Quest, the learning activities that students of all ages can do with the live telescopes. Because don't forget, Slooh members do this kind of stuff every night, not with a lunar eclipse, but they're pointing and controlling Slooh's telescopes to any objects that they want. It could be the moon, but it's more likely to be a distant galaxy or a nebula, or maybe one of the planets, or our special solar telescope where we look at the sun every single day and track solar activity. Might be a near-Earth asteroid whizzing past Earth. There's one whizzing past tonight, I believe, that I kind of got in the news, but you know, is actually quite an old discovery. I think it was 1993, something like that. But anyway, we are going to take a short break, and we're going to be talking to John Bovair about Slooh's moon-related quests. Don't go anywhere. Welcome back. We couldn't stay away, could we? Because look at that, just as I down tools to take a sip of tea, they did exactly what I was hoping they were going to do. And you saw they suddenly changed the exposure level, a setting on their camera, and we can see that the illuminated part of the moon is now totally whited out. But they've done that so that we can actually see the dark area. So that's the portion of the moon that Keith explained right at the beginning is in the Earth's umbral shadow, the really dark central shadow, and we can see some color. Can everybody see some color? Tell me in chat or anything like that, because that's definitely looking like it's taking on a bit of color to me.
It definitely does to me in the studio. And we actually have a question in our Q&A section from Kirsten Swan. Why does this feed show more shadow than what seems to be on Canary 1 or on the wide field in Canary?
Oh, well, let's take a look at those. So let's show those, because the only feeds that I can actually see at the moment, studio, are the ones that you're showing. I can't switch between the other feeds. So if we could have a look at the telescope feeds. Okay, I don't think that is. I mean, part of this is about the exposure levels of the various cameras. And also with Slooh's telescopes, these ones, these are very large telescopes with ultra sensitive CCD cameras on the back of them. We can't adjust their exposure on the fly. So this is taking the same exposure level and doing the same real-time processing on every single image that comes in. And what you can see there, in fact, it was very evident in John Larson's feed, wasn't it? That the shadow wasn't this very defined, sharp there. We can see it. There's a grading of that darkness. So I think that's really what's accounting for that, what looks like a different extent. But what we know of with a lunar eclipse, and Bob said this, unlike a solar eclipse, you have to be in exactly the right place on Earth to be able to see that. With a lunar eclipse, if you can see the moon during the period of time that it's being eclipsed, you will see the eclipse. And so we're seeing this. It's, yeah, I think that's the answer. So anyway, listen, we need to move on. So welcome back to the online telescope. So yeah, I'll do the proper reset. This is the way we do it. Welcome back to the online telescope's live coverage of the full flower supermoon total lunar eclipse. There's a mouthful for you. John, thank you very much for setting up this this feed. It's absolutely brilliant. Now, we're going to move on. We're going to talk a little bit about what students and other members, students of all ages actually, do at Slooh. And I'd like to welcome our Director of Curriculum, Dr. John Beauvert, to the Star Party to tell us about how students, use the live telescopes to learn about space and explore the universe using our learning activities called Quest. Welcome, John. What do you make of these live feeds?
Hey there, Paul, and everybody else. I'm loving these live feeds. I'm just going from telescope to telescope on my other monitor, watching what's on the live feeds here, enjoying these awesome conversations that we've had so far for the last hour and a half, and really looking forward to what's going to happen coming up soon, for sure.
Yeah, so actually we're running now for, what is it? Have we got another hour? Is it 2 hours? It's another 2 hours, isn't it, that we're running for? So this is really cool. And of course, John, Bob said this, and we had the timings up right at the beginning of the event as well. So we've got the total eclipse beginning in 25 minutes time, and that's actually going to last for an hour and 25 minutes. So we've got this really lovely leisurely pace for a celestial event that we're covering. We were talking the other day, and we were saying I'd gone to Kenya to capture, with the Slooh expedition, to capture 13 seconds of totality for a solar eclipse. We travel around the world for these events that take seconds or minutes, or catching a near-Earth asteroid whizzing past, and unless we time it absolutely perfectly, we miss it. But here we've got this event, which is basically lasting, what, 5 hours, or something ridiculous like that. And we're just able to take it in far better. And the best thing, I think, is it gives us the opportunity to talk more about the online telescope and Slooh. And that's what you're here for. So you're
Absolutely.
Director of Slooh Curriculum. Tell me, I've kind of hinted at it, but what are Slooh Quests?
So on our platform, what we have are Slooh Quests, are interactive lessons that are aligned with the current science standards that challenge you to use the online telescopes to collect and analyze data to form your own conclusions. Now, of course, Quests teach members how to explore space in a self-directed manner while completing various learning activities that challenge them. And various studies have shown that we are more likely to retain information if we complete tasks that apply the stuff that we learn. Yeah. And so that's what they're so awesome about Quests. They are for not only students, but also educators, families. They're for everybody to go on, embark, enjoy, and explore space.
So other than a load of knowledge and some what we call gravity points, because everything you do on Slooh earns you gravity points, what else do members get when they finish a quest?
One really fun thing that all members get when they finish quests is a really cool infographic poster that showcases the images that they caught throughout the quest itself.
Have we got any we can show?
We actually do. There is
well
there
done.
It is, the lunar phases one. This is, since we're here for the lunar eclipse, I think thought this would be a perfect one to show everybody, what you get from a quest. All of these lunar phases images comes from the online telescope. So it's fun to sit down on a month, chart out what days you want to go on your missions, and the quests tell you exactly when these phases are going to happen. It tells you how to control the telescopes. It basically does it, without doing it all for you. It tells you exactly how you need to do it. And so it's really fun when you make these posters. The ideas that you're learning throughout the quest, they really get solidified in your head. And then the next time you want to know why a lunar phase looks like it does, you can pull up this infographic poster. You can actually print these out on a big plotter, because they're many thousands of pixels by many thousands of pixels in length and width. So these are awesome. This one particularly is from the Moon Lunar Phases quest.
I love this. I love this quest, and it really showcases, what we were talking about earlier with Bob, and we can see that different curvature, can't we, between a lunar phase, say that bottom left one, the waxing crescent moon. Is it possible, Studio, to go back to our live feed to compare that curvature? Because I bet we could see it quite clearly. So, yeah. Kind of.
Yep.
Look at that. Oh, we can definitely see some peachy copperiness coming in here. The other thing to keep an eye open for, John, at this stage of the eclipse, as we get closer and closer to the total phase, is we might start seeing some stars appear in the background. So that's something worthwhile to keep an eye open for. Now, did you mention
Awesome.
Did you mention learning progression there?
I think I might have. So we're debuting this new thing called learning progressions. And learning progressions, you can think of them as a series of quests, and they surround some particular theme. And this is the one that I want to debut for everyone tonight. This is called the Earth Moon system.
Is this an exclusive?
I mean, anybody here can see what this list looks like, and if you want to write this down so that you can start going on these yourself, you can. So you're not.
But we haven't told people about this yet, have we?
We haven't.
These learning progressions.
This is a super secret exclusive in that regard. So you will be seeing these pretty soon. But I wanted to show everybody, tease these cool learning progressions that I've been working on with everybody on the Quest team. And like I said, this is our first one. This is surrounding, of course, the moon. Perfect place to show everybody it for the first time. And these series of quests, learning progressions, it builds upon themselves to have a more successful learning experience. So as you go from quest to quest, the material that you're learning is building on itself. It's like you're building a nice foundation to become a true lunatic, which is what we want you to be once you get done with this learning progression, to be loving the moon in all different facets, from the science to the mythology, from the history.
It's great. So yeah, there's Mama Killer Inca Moon. I haven't done that quest yet, John. Now, you wrote that with Milton. Milton, his storytelling capabilities are just second to none, aren't they?
They are. Yeah, Mama Kia is a fantastic quest. So you can dive deep into all of those lunar myths that Milton was talking about even further.
Can we just go back to that quest poster, because the full moon looks like it was on the opposite side of the Earth from the sun. The diagram makes it seem like a lunar eclipse should be happening, every single month. Now, we discussed that earlier, but we got lots of new people coming into the Star Party, John. Why aren't we getting, if the full moon always goes behind the Earth in comparison to the sun, why don't we get a lunar eclipse every single month?
It is a fantastic question, because you can even ask the similar question every time we're in a new moon phase. We should get a solar eclipse, and we don't. There is an image, if we could pop this one up, Studio, it's number 3, the tilted lunar orbit PNG, or we can go to the Mystery of the Changing Moon quest. There is a perfect diagram that really shows this. Here it is. And we did see a video of this earlier, but here you can see it in more of a static form, seeing the moon's orbit going around the sun. Now, of course, Bob Berman just let us know that the moon's orbit itself makes one complete rotation every 18 years. But if you relax that condition, you can see that there's going to be some locations, like on the right side, where the shadow of the moon and the shadow of the Earth do not hit each other. So there we won't have a solar eclipse or a lunar eclipse. But if we go to the top configuration, you can see that, all of a sudden we're going to have a solar eclipse there, because the moon shadows on the Earth And then if we go to the nearest configuration, this is where we're at tonight. We have a lunar eclipse. The umbra, the Earth shadow, is going to engulf the moon. Just want to take a quick peek over. It's getting even closer and closer into the shadow. So this is something that you get to learn all about when you do the Mystery of the Changing Moon quest, which builds upon things that you've learned in the Lunar Phases quest.
Is that what you were just looking at, John? Because I'm only seeing what the viewers are saying in the live stream. So, wow, that's looking decidedly coppery to me. How about John Larson's feed in Nebraska? What's that looking like? We got some. Oh, that's interesting, because those two colors are incredibly similar, aren't they? And that's two totally different setups, different cameras, stuff like that. But that's why I always think of this as being peachy colored. I love that. That's remarkable. So, John, that kind of takes us on to another subject. So we spoke to Keith earlier about some of the phenomena we see during a total lunar eclipse, but some viewers might have missed that. So we're approaching the total phase of the eclipse, as we can see, when we're hopefully going to witness a deep red, or so-called blood moon. Why does it change color?
That's a really fantastic question, and I love talking about this. So when this is, there's actually a diagram, studio, if you could pop this one in. This is the blood moon diagram, and so we have the Earth's shadow, and you would think that it would just cast no light on the moon because it's a shadow. But what ends up happening is the sunlight actually passes through. There's a different one. There we go. This one here. So what's really interesting about this is the sunlight passes through part of the Earth's atmosphere. And a few things happens with this. So there's a phenomenon called Rayleigh scattering that basically changes the direction that the sunlight is moving. So at first, all of the sunlight's moving towards the sun, as you can see, but some of the light is deflected away. And what's interesting about this is the more blue or the more energetic the light is, the higher the degree of deflection is. So this is actually the reason why the sky is blue during the day. But in terms of what's happening tonight, all of that blue light all the way to green is scattered away in different directions. And there was some awesome imagery that was showing this earlier. But the colors that are left, the reds, the oranges, some of the yellows, they actually pass through the atmosphere, and it acts almost like a lens, and it kind of the light refracts through the atmosphere, and it kind of gets focused or deflected right towards the moon. Now that's kind of like the hard scientific explanation of what's going on. But if you really think about what's going on, is all of these moments all around that bubble of the atmosphere, those are the sunrises and the sunsets that are occurring at that moment. So really, what I like to think of with the blood moon is you're watching, perfect time for that segue. You're watching the sunrises and sunsets that are occurring on our planet right now. That light from those are hitting the moon. So I like to think of them as maybe sunrise, sunsets, eclipses, but I don't know. Blood moon.
And we've got a great animation later, John, that we'll show, which gives you what an astronaut would see if he or she was standing on the surface of the moon during a lunar eclipse, which we'll ask Bob Berman in 10 minutes time. Did they ever encounter that on the moon? I don't think they did. But John, just go back to that studio. If we could go back to that diagram that John had put together. Am I mistaken, or was the sun image taken with the Slooh Canary 5 solar telescope?
Yes, it was. It absolutely was.
Oh, look at that. So that image of the sun is a real image that you took of the sun using the Canary 5 solar telescope.
Absolutely, it is.
Very cool. Very cool indeed.
The moon... the moon too, it actually is from Canary 1. It's the last harvest moon that we had. And the background is a background stars from a quest, Are We Alone, taken in with our Chile 2 telescope. So there's
the only thing we don't have a telescope to take an image of is the Earth, and in this diagram.
That's right.
That's pretty good going.
And this Earth was actually taken by Apollo 17. And if you want to see that, that's actually in the footsteps of Apollo astronauts' quest, which we'll talk about later on.
Ah, we are. So what are we going to talk about later? Oh, look, there it is. We're going to talk more about this later on, John. But you know, go on. We've got a little bit of time, so tell us a little bit about it now.
Okay,
I love this quest.
This quest is so much fun. So now, this is all about the Project Apollo. It starts with the tragic beginnings of Apollo 1, but it goes through the first landings on the moon of Apollo 11, all the way through to the final landings of Apollo 17. Gives a complete history of everything that the astronauts did on the moon. And the fun thing about this quest, at least in my opinion, is super fun, is we want to use the telescopes to actually find the locations of all of these landing sites. Now, earlier, Bob Berman taught us that the day-night line on the moon is called the terminator. And what's really fascinating about the terminator is the phases are due to the geometrical configuration of where the Earth and the moon and the sun is. And so when you're, unlike tonight, when it's in different phases, you can actually see a lot of shadows being cast on the lunar surface. And this actually makes it a bit easier to pick out a particular location on the surface of the moon. And so students have to use the telescopes, plan out their missions where the terminator are near the landing sites. And then after a successful mission, they take those landing sites and a little lunar module sticker and actually have the astronauts land on the surface, actually just like my background is right here. Excellent. So it's a really fun quest. And if we pop up the poster on there for just one more moment, I just want to point out that on the right column, we have the day side on the right side of the moon. Or excuse me, on the left column, we have the day side on the right side of the moon. And on the right column, we have the day side on the left side of the moon. So there was a little bit of artistic expression that members can put forth in this poster. Do you want to have the day night be on the right for the whole side? Do you want it to be on the left? Do you want to switch it up? That's all up to you and your artistic expression.
Because, you know, just so that it's clear for people, this poster is at the end of the quest when somebody's completed it. So all of those boxes are just empty beforehand. So they have to use the online telescopes to capture their images of the moon at various phases. And those get automatically inserted into these posters, John. That's right, isn't it?
That's exactly right. And the gray text that shows up here is not on these either. Those are something that you have to put in. You have to put in when were the phases? What day did you go on these missions? Because this is a very personal poster. No two posters of these are going to be the same. And that's such a cool thing about all of the quest posters.
It is. Yeah, and it's personalized. I see up the top left-hand side, August 2nd, 2021. John H. Beauvais, very nice, John. Studio, while we've still got John, and before we go back to Bob in 5 minutes' time, can we have a quick scan through the telescope feeds? Because Phoebe in chat in the Zoom webinar, don't forget all Slooh members can watch. No, hold on a sec. Go through this slowly. Don't forget, all Slooh members can watch this on the live Star Party page, and you can see all of the feeds at the top, the different telescopes at the top. You can click on those and then press that little camera button, which the studio just did. So Phoebe was pointing out that Canary 3, the Deep Sky Telescope, might show us some interesting images. So what we said earlier is this particular telescope will come into its own near the end of the or during the total phase. And we've got this particular telescope is set up at 3 different exposure levels because we basically had to experiment with it. It has a very short exposure, which this looks like it's the very short exposure. It has a slightly longer exposure and then an even longer exposure. So if you keep, look, there you go. So there's the second exposure. When this goes into the total phase, you should get some really, really cool snaps using this particular telescope. By the way, it doesn't look round. I think that is because it's Why is that? I thought it was because of the saturation and the bloating, but we'll keep an eye on that a little bit later. So let's have a quick look at Chile wide field. What do we got there? That's quite a close up. Actually, we have got Chile 3, I think, was also online this evening. I don't know if you brought that up, actually, Studio. You'd have to go to the telescope page to see that. I don't want to break everything, but so Chile 3 we only use for special events. Here it is. Look at that. So this is an ultra close up. It's got a tiny field of view, which is not great for seeing an eclipse. And the quality of the YouTube stream looks like it's set to low quality, but look at that. We can see the color even in close up of the moon. So maybe, so if members are watching, if you go to the Chile 3 tab, open it up on YouTube, because then you can set the quality to high quality, because this is a high def stream. But let's take a quick look back, if you could, Studio, to Canary 1 and 2 again. I'd like to see that, and then we will move to a break before we invite Bob Berman back. So I'm asking the Studio to do. Oh, look at that. That's rather good, isn't it? So here we are with this kind of part of the eclipse, which to me kind of echoes the diamond ring of a solar eclipse, where we just land up with this one very highly illuminated. So don't forget, Canary 1, Canary 2, they are going to continue showing grayscale images, because they are ultra sensitive CCD cameras, which are only grayscale. So keep an eye on those, but keep an eye on Canary Deep Sky as well. Have we got, by the way, Studio, our other feed from, who is it, Nick? I'm not sure if we've got his feed, or John Larson. Be nice to go back to his one.
We'll go back to John. Yeah. This is what's happening, I guess, in Dallas, Fort Worth. There seems to be.
There's cloudy by the looks of it.
Yeah.
So there's
okay, that's what's going on
Nick's
there.
rig.
I've been going back and looking at it to make sure. But here we are back in Omaha.
Wow, look at that. The color is really coming in there.
It's like kimchi.
That's brilliant. So this is a live stream that's been set up specifically for us by Slooh member John Larson in Omaha, Nebraska. And wow, I think we should stick on that for a little while. John, you're going to join us a little bit later to tell us more about some other quests as well. So thank you very much for telling us so much about it already. We're going to disappear. We might have a little break. It depends what the Studio want to do. We could stay on this, but make sure, please, Studio, we are back talking to Bob Berman at what are we talking about? I think it's at 29, is it? Yep, 23:29 UTC. So a couple of minutes away. Actually, let's stay on the live feed if you wouldn't mind. But I'm going to have a quick drink. Thank you very much. We'll be back very quickly. Hello and welcome back to the Online Telescopes live coverage of the best celestial event we've seen so far this year. I'll ask my next guest whether or not he agrees with that. It's the total lunar eclipse of May's full flower moon. And I'd like to welcome back our special expert guest and astronomy author, Bob Berman. Welcome back, Bob. What do you make of this live feed? It's looking rather good, isn't it?
Oh, this is the time. This is the time of maximum strangeness, I would say. If you were going to just spend 1 minute or 5 minutes looking at a total lunar eclipse, this is the time. Very evocative of the planet Mars, isn't it? It looks like the orange color of Mars with a polar cap on one side. Looks like a little really evocative of a telescopic view of Mars. But this, I think, is the loveliest point. Now, Totality again, we got to emphasize this because coming up in just a couple of years, on April 8th, 2024, we're of course going to have a total solar eclipse seen from much of America. And too many people don't realize the full glory of totality in a solar eclipse. So let me emphasize, you know it, Paul, and those who have seen it know it, that it's life-changing. A woman I saw in during the 1970 totality in Puri in India said that she felt it was the home of my soul, is how she described it. People weep, animals go crazy, all sorts of things happen. Pink flames called prominences leap from the edge of the sun. Filaments of the sun's atmosphere, the corona, goes farther from the sun outward, radially outward than you'd think was possible, and all sorts of things. Not here. With a lunar eclipse, what will happen is that it will be fully orangey red, usually a little irregular in color. We're seeing that again right here. Where the moon is, the part of the moon that's most centrally in Earth's shadow is darker, that's near the top. And this is typical. And what it shows us, because it's not too dark and it's not too light, it shows us that Earth's atmosphere is normal right now. And with all the craziness going on in the world, the moon is at least showing us that the air we're breathing, our atmosphere is normal right now.
This is a marvelous shot, John, isn't it? From John Larson's Slooh
Marvelous,
member. And
marvelous.
It looks so three-dimensional, doesn't it, over on that right-hand side? So explain to us, because we saw it in the other feed as well, Bob, you know, and this is where, you know, this lunar eclipse is a far more gradual affair than a solar eclipse, where we see these very specific moments of totality and the diamond ring and Bailey's beads and all those kind of things. This is still deepening, this eclipse, isn't it? And maybe you could explain to viewers what I mean by that. And we're looking at still, there's a bit of lightness over there, but the left is getting darker and darker, and it's going to continue to do so, isn't it?
Quite right, because the moon is venturing more centrally into Earth's umbral shadow, whereas in a solar eclipse, it's a frantic, almost nerve-wracking affair, because very often totality is 2 minutes, 3 minutes. The one coming up will be as long as over 3 minutes in most places, very close to 3 minutes. But here we have an hour. So it's, you know, you can take out a paperback book. You could read a few chapters of the book. You could look away if you wanted to. With the solar totality, oh no, every second is precious, and there are things to see that only appear during totality. And so 2 years from now, make sure, all of you, that if from your location, from your backyard, if you read that it will be 97% total from there, but driving 100 miles will get you into totality, drive. Get yourself into totality. Totality is everything. This is a different story. With the moon, everyone on Earth sees it as total right now. You can't escape totality. You can't drive to a place where you won't have totality. So in a way, it's very opposite, and there it is, and very lovely. You know, looking like really nothing else. We have only one moon in our sky, and what other planet can boast that? Pluto, and there it is, turning weird on us.
And we're starting to see some stars appear as well, which I guess, you know, is a common feature between a lunar eclipse and a total solar eclipse as well. But Bob, one of the things I wanted to look at here is, and this is the kind of fairly familiar view where the moon isn't too big in the field. But what I'd like the studio to do, so look at how evenly the color seems to be cast. If they could switch back to John Larson's feed in Nebraska. So it's not up at the moment. When you can, studio, switch back to that, because one of the things that I thought was quite interesting there, Bob, was how much contrast we saw between the dark seas on the moon and the lighter areas. I don't recall seeing, you know, a lunar eclipse and seeing that huge contrast between the light areas of the moon and the dark areas of the moon. Maybe you could talk a little bit about that.
Yeah, the moon is actually one of the darkest areas, objects in the known universe. We use the term albedo for reflectivity. What percentage of the sunlight gets reflected? For example, freshly fallen snow has an albedo of about 97, meaning it reflects 97% of the light that hits it. Coal has an albedo of about 5. It only reflects 5%. Black paint does the same thing. So that's why it looks black, because it's reflecting less light. So with that in mind, the moon's average albedo is very, very nearly 10. So it only reflects 10% of the light that hits it, which happens to match the albedo of an asphalt driveway. So if you've ever had your driveway paved, well, and of course you've visited people with driveways. I mean, we're not all from the country bumpkins here. That's as dark as the moon always looks. So the moon is a very miserable reflector of light. Now, those dark areas are solidified lava areas called Maria, the plural of mare, which means seas. They have a strange nomenclature. I mean, very inconsistent. All those dark blotches, which the ancients, including Galileo, thought were oceans, although he was skeptical, because if they were oceans, they would reflect the sunlight and they should brighten up from time to time, and they never do. So he thought, well, maybe they're not oceans, but that's what they were called. Mare means, in Latin, means a sea. And they're all named for either, and this is so strange, either human emotions or weather phenomena. And you can't get too much different from that. So, for example, the famous Sea of Tranquility, the Sea of Serenity, the Sea of Crises. Imagine going through emotional crises. That's one of the seas. But then you also have the Bay of Storms, the Bay of Rainbows. You know, in other words, weather phenomena. The ocean of rain. You have all sorts of either weather phenomena or human emotion. So those are the dark areas.
Oh, but we've spoken about the naming of the seas before, but I don't think we've ever said who named them. Who's responsible for naming? Who was responsible? And even now, who is responsible for naming features on the moon?
It was mostly Riccioli, going back about 3.5 centuries. But then to make it officially, it's the International Astronomical Union, whose president, Deborah Elmgreen, who's also a professor at Vassar College. Well, she just gave up the presidency of that. But it's the IAU, the International Astronomical Union, that makes things official. So if a new crater should be formed by an impact on the moon, and somebody suggests a name, it will only be official when the IAU says it is. And they're very specific. No whimsy, no cartoon characters. And you have to be very, very in keeping with traditional names, and this applies to all celestial bodies, all the solar system features.
So this is the Canary 3 telescope. Hasn't quite come into its own. I'm still hopeful, because last time there was a moment and it came in right at the right spot. Oh, look at that. Oh, Gretchen's got some images coming in as well. Thank you, Gretchen. Is this looking through the trees? So this is Gretchen, who is in Arizona, I believe. Is she? She's probably trying to multitask at the moment. How's it going, Gretchen?
Yeah, it's going well, running in and out, and we had a bunch of haze, but I am just trying to upload a few right now.
Excellent.
Really cool thing. There was this tiny little star, the bottom left of the moon, and as the moon was like eclipsing and turning red, the star like disappeared behind the moon.
Wow.
It was just like a really cool sight, you know, these things that you just end up noticing and observing because you're staring at the moon, right?
And there is your latest image that's come through. It's been cropped a little on the
Cropped a little
on
weird.
the right hand side. So if you can center the moon in the view so it doesn't get cropped, but that is quite a rich red. So I'm looking at that on the screen. Hopefully you can see it on the screen. How close is the color that we're seeing to the color that you're seeing with your naked eye?
It's that red.
Wow.
It is. I mean, it's behind. Well, so you can't see it. You can't see it right now because it's really eclipsing. So you can barely see it out there. Yeah.
But we can see the star actually when we're zoomed into this. So
so that's that little tiny star.
Wow.
That's the one I was trying to get, that little tiny baby star. Yeah.
Excellent. Well, thanks, Gretchen. We'll be catching up with you a little bit later, but keep those images coming in. So please, everybody, start checking out Mobile 3. That's Gretchen in Arizona. What we've talked about in the past is when we've been talking about full moons, and of course, a reminder that a lunar eclipse can only occur at full moon. It rises at the same time the sun is setting, which actually we saw in the Canary Islands earlier. I hope you were checking out some of the other cameras that we have there, but we see the shadow of Pico del Teide, the volcano, pointing down as the sun's setting behind in the west, and the shadow points directly to where the moon is going to rise, which is always an absolutely lovely sight. But we have talked in the past, Bob, about full moons and some of the connections of a full moon to nature. A lot is happening in the natural world, which is prompted by lunar phases. And is that related to the tidal impacts of a full moon?
Good question. And, you know, in the Farmer's Almanac, the old Farmer's Almanac, our readers look for that almost more than anything else. Time is for planting, and there've been so many traditional supposed effects of the moon. I'm skeptical about most of them, but you're right about the tides in that there's no question that the delay in the rising of the moon from night to night, which averages about 50 minutes, also produces the tidal delay, full high tide, the next high tide or low tide. And it's there in those the areas where we have marshes and brine marshes and creatures that live there, and they're predators such as gulls. And yes, absolutely quite right. Their lives revolve around the tides, which in turn revolve around the phases of the moon. So it very much is connected with many aspects of life on Earth.
Oh, but I've got a diagram that I'd like the studio to put up. By the way, when we're watching this feed, look at the little white dots, the stars in relation to the moon, and just watch it over the period of 5 minutes, and you can see what Bob was talking about earlier, just how far the moon is moving across the sky in relation to the fixed stars behind. But studio, could you bring up the diagram of the timings? Because I want to illustrate what Bob was talking about earlier about how much darker, how much deeper the eclipse gets as the moon continues, as we can see it here, passing further into. It's the one with the circles on it and the times on it, please. So, because Bob, we're still seeing, this is one, yeah. So we're still seeing some graduation of brightness across the moon at the moment. Can we see that full screen, or the fixed diagram that we've got of this, please, studio? So there we go. There's a penumbral phase where we didn't really see very much happening. There's the start of the partial phase, color coming in. But this is what we're talking about, Bob. So describe to me really what's happening here when we say it gets deeper and deeper.
Yes, well, the center of the umbral shadow is the darkest part of Earth's shadow. As John...
Stop there, please, studio.
Yes, as John very articulately pointed out earlier, the refraction of the sun around the atmosphere of Earth is what colors our shadow. Actually, if you were on the moon at the time, you'd see this brilliant red halo around the pitch black Earth. Essentially, all the Earth's sunrises and sunsets merged into a single wedding ring like halo or glow surrounding the pitch black Earth, with the sun being behind it. Now, the sun only appears 1/4 the size of the Earth from the lunar sky if there were astronauts there. So it's buried behind the Earth right now.
Oh, this is the lovely animation that we.
Oh, beautiful, beautiful, beautifully done. And let's see if the animation includes that ring. Yeah, yes, it does to an extent, but
I think it will. I think it will. There you go.
Yeah, very nice, beautiful. Yes.
Wow. So what a view that would be. Now, listen, when I was a kid back in the 70s, I was drawing lunar bases. And frankly, there should have been lunar bases by 2010 in my kid's head. It is a tragedy, isn't it, Bob, that we have not set foot on the moon. For how many years is it now?
Well, the last one was in December of, what was it, 72?
We have the capability, but we're choosing not to. What went wrong? Why aren't we on the moon? Why aren't we exploring even more? Why aren't we using it as a stepping stone for human exploration of the solar system?
There's a lot of different ways of thinking of it. One of them is that maybe Richard Nixon canceled the final 3 Apollo missions, not because he was still jealous of Kennedy, who, of course, got all the credit because of his "let's go to the moon before the decade is out" speech that had been made almost a decade earlier, but because of something that's actually quite logical, which is that keep doing it enough and somebody may get killed or hurt. I mean, we almost had that with Apollo 13, of course. These missions are dangerous. The astronauts are very brave to participate in them. And we already now had 6 successful landings on the moon. Why keep it up until somebody gets hurt? You know, so the idea was, let's quit while we're ahead, cancel the remaining missions, and the Apollo program will be deemed a great success, which it was and still is. So going back, well, that reasoning still applies. It's dangerous. We've already been there. Is the public really on board, or is this one of those things that are, been there, done that? Do we remember the second people who climbed Mount Everest? Everybody remembers Hillary and Tenzing Norgay, who were the first, but who knows the names of the second? So is this really going to pay off in terms of public excitement? And is it worth the risk? I'm giving you the negative reasons because I think that's what you wanted to hear.
No, not at all. I was just interested to hear your perspective, because you've written so much. I mean, you've met how many astronauts over the decades?
Yes, many of them, including a fascinating bunch of hours with Buzz Aldrin, who I couldn't believe is still angry at a bunch of things that happened during the and leading up to the his Apollo 11 mission. But of course, then you could give the reasons to do it. But there's a lot of people who say that we can send robots, as we have done to all the the Voyagers and the Galileos and now the New Horizons that went past Pluto and took those fabulous images, and there was no risk of any human life if we send things robotically. We can even collect more soil samples, those hundreds of pounds of moon rocks. We could get more if we wanted them. We don't have to risk the lives of people. So you could really argue it either way, I think, Paul.
Yeah, I don't know. We've had this discussion before, but I don't know. To me, the sense of adventure, it's what explorers did. Those explorers were the people who fascinated me at school. It was the only bit of history that I enjoyed. It was that risk, that endeavor that people went on. But more than anything, I look at the pace of the Mars rovers moving, what, a yard in an hour or something like that. And then I look at their fairly basic, I know they're very high tech, but a person's hand, a pair of eyes, what they could do on the surface of Mars in 2 hours would probably eclipse what a single rover could do in a month.
I see.
And
there
that's
it is. You're so articulate. It's really a pleasure listening to you. Being British and listening to that genteel accent, I sometimes think of the Brits as maybe being a little fearful and conservative, but you're a living proof that exactly the opposite is true. Whenever I start thinking of myself as, oh, here I am in a house surrounded by, we see bears out the window, and I'm living near Woodstock. It's so cool here. And then I realized, but Paul lives a stone's throw. He lives near Stonehenge. I mean, what's cooler than that? Or I think that, I've owned an airplane for decades and a pilot. And then I learned that Paul not only has an airplane and is a pilot, but an aerobatic pilot who does things like flying upside down and stuff that I would never have the guts to do. So, when you talk about these things going back to the moon, I listen to you.
Yeah, well, that's very kind of you to say. But, it's that sense of adventurism, isn't it? And what I love about the Apollo and the Apollo missions, and we'll talk to John again about the quest about the Apollo landing sites, but it was that sense of adventure. And of course, all of those early astronauts as well, they came from, a lot of them were test pilots and stuff like that. So yeah, all of this is my cup of tea. But look at this, Bob, we're still getting, by the way, studio, that was brilliant when you had that diagram up at the same time as this feed, because what it's showing us really beautifully is we're still away from the maximum eclipse, because at maximum eclipse, the moon is going to be about as even as we will see it, evenly illuminated in this red, but we can still see it's a lot brighter down on the left-hand side. It's a lot darker up on the right-hand side. We know that here we go. So this is actually around the opposite way, in fact, because you'd have to twist one of those the opposite way. But we are a little over 15 minutes away from the maximum eclipse. Now, Bob, what I wanted to point out and ask you about on this diagram is, we saw right at the beginning, Keith was talking about the apparent tilt of the moon's orbit, which is why it doesn't always pass through the Earth's penumbral and umbral shadows. And we can see here that even though it is passing through the umbral shadow, so we're getting a total eclipse, and that period of time is something like 1 hour, 25 minutes tonight, presumably the moon could be passing through the umbral shadow centrally, in which case it would last a lot longer, wouldn't it?
Yeah, that would be the maximum length of eclipse. We're having another total eclipse on November 8th. I think that one's going to be fairly central also. And that one also will be visible from at least parts of the United States, the entire eclipse. So we'll have another shot at this. Whenever you speak of the brightness, it brings up an opportunity to explore something that very few people realize, and that is the moon's actual brightness. As we know, it lights up the countryside if you're in a place away from artificial lights. But how bright is that moon? We started out with the full moon before the eclipse. We'll be going back to it in a while. I mentioned that it's 450,000 times less bright than the sun, but even that doesn't capture it. But here's a good way of thinking of it, and how our eyes change their receptivity to brightness and darkness. It's not just that our pupils change their size, we actually change our sensitivity to brightness. So here's an interesting fact. If you looked at a black cat in sunlight, well, it looks black. And if you looked at typing paper, printing paper, by the light of the full moon, it looks very white. But if you could see them side by side, I'm talking about the printing, that white printing paper as seen by the light of the full moon, and somehow hold it next to the black cat as illuminated by the sun, you know what would happen? Now that black cat would not just be the white object and the paper would be the black object, but that black cat would now be 2,000 times brighter and whiter than that printing paper. You wouldn't even be able to look at that black cat because it would be so brilliantly white. So they would switch places. So when we see that moon in the sky and we say, oh yeah, white moon, and I mentioned earlier that it's actually one of the least reflective, one of the darkest, one of the lowest albedo objects in the known universe. One of the consequences is, as I've just pointed out, it's actually not the brightness that we might think.
Wow. Thank you, Bob. As ever, I know you're clouded out there, so I hope you've enjoyed some of the live views that we've had today.
It's a pleasure.
We always enjoy your commentary, so thank you very much for that. And hopefully we will see you back very soon, because we are starting up our public star parties once again. So who knows, it might be a near-Earth asteroid whizzing by, could be a planetary conjunction, it could be an occultation maybe. But well, you've got any events you can point us to this year, Bob?
Well, you know, there's that eclipse, and then later we'll be doing the Aurora tour. But no, I think Slooh has it very nicely
got it covered.
You got it well covered.
Thank you so much for joining us tonight,
My
Bob.
pleasure.
It's always a pleasure. Thank you very much.
Thank you. Thank you.
Now then, joining us, before we move on, could we please go to mobile 3, which is Gretchen in Portal, Arizona, because there was a quick flash of the latest image that had been uploaded from there, and it did look rather good to me. So this one with John Larson, very quickly he's going to have to change probably the exposure that he's taking as the moon darkens and darkens and darkens. And this is always different. Oh, look at that, Gretchen, that is wonderful. Is that an accurate depiction of what you're seeing in the sky with your naked eye?
It is. It is. It's absolutely great. It's pretty dark. I ran out there a few minutes ago, and it's getting pretty dark.
Wow.
But yeah, I was like, wow, incredible. So it's kind of hard to see. That was probably like a good naked eye one, and this is a different star on the other side. So apparently the stars are loving to hang out with this eclipsed moon. They're like, we love you. We're going to hang close.
Yeah, no longer in its limelight. So I am interested, and we'll talk about this more in the round table a little bit later in half an hour's time, when we're all getting together to have a chat about all of this. I am interested to know what the other people who are not necessarily astronomy fans, but the other people that you're with there are making of this event.
Well, I'm super lucky because my friends are, well, some are astronomy, then there's only just a couple. It's my friend and their brother, and so, but they're interested. And Bruce, who's the one, this is their house that I'm at, he and his wife, he feels like this is the best eclipse he's seen.
Wow. Oh, well,
yeah.
That's interesting to know. And I have to say, I mean, the colors on this, and we are still kind of 9 minutes away from, you know, the maximum eclipse, where we're expecting to see a more even color over the moon. That's going to be interesting. Anyway, we will catch you in about half an hour's time, Gretchen. So thank you very much. Back to the Canary Islands feed there, which we will probably stick with. Now, don't forget, here at Slooh, we do this every single night. Slooh members, students, lifelong learners, we've got a new family subscription, which is a bit like a Netflix subscription. You get multiple accounts for the entire family to control the telescopes, to do the quests that we are going to be talking about in a minute. But anyway, actually joining us after a very short break, because I've got to rest my voice, we've got Slooh's Director of Curriculum, Dr. John Beauvais, is going to join us, telling us more about how students learn astronomy with the online telescopes, live telescopes, and educational platform. We are also going to witness the moment of maximum eclipse that occurs at 11 minutes past. So please shout, interrupt John and I when we're having our chat. And in about 20 minutes time, we'll welcome back the experts from our community, Keith, Milton, Gretchen, and anybody else who's in the Zoom webinar, and we'll have a chat over the remaining part of this total phase, which is going to be quite cool. So anyway, we will be right back. Well, I will be right back in a few minutes time. Take care. Bye. Hello and welcome back to the online telescope at Slooh's live coverage of May's full flower moon total lunar eclipse. I just sneaked out to look out of my window, and my dismay, it's getting daylight, but it does still look cloudy, so I would have missed it anyway. So thank heavens we've got all of these live feeds. The one that we're looking at the moment is from our partner in the Canary Islands, the Institute of Astrophysics of the Canary Islands. They run an organization called skylive.tv, and the guys there have been up all night. They watched the full moon rising because the observatory is very high altitude, 8,000 feet, 2,000 meters altitude on top of a volcano. So we can look right down on the ocean, and they saw the full moon rising over the neighboring island of Gran Canaria. And this is what they've been looking at ever since. It's absolutely spectacular. Anyway, I would like to welcome back Slooh's Director of Curriculum to talk more about how students of all ages learn about the universe and explore space every night with our live telescopes. Dr. John Beauvais. Hello, John. What do you make of this?
Paul. This is so beautiful. Just seeing the progression of the evening and the umbra engulfing the moon has just been spectacular. I'm keeping an eye on Canary 3 too, and it's looking really nice too. You're seeing a lot of the Maria.
We are still getting quite a distorted view though, aren't we, with Canary 3? So I was trying to take a little bit of a peek while I was talking to Bob, which is a bit rude. But what I was going to ask you, John, is we've still got, an hour or something left. What is that, Canary 3? Oh, it has done it. Oh, is. Brilliant. Okay. So while I was talking to Bob, I made some tweaks to the real-time processing. So it's no longer squished, because it actually was squished. So anyway, what I was going to say, you'll be relieved. I was going to say, John, would you mind taking the seat and let me go off and see if I could sort that problem out? But the problem is sorted, so we can carry on talking. Now, we were talking about quests. So for people who weren't around an hour ago, just explain very briefly what a Slooh quest is.
So
please.
Slooh, absolutely. Slooh quests, they're interactive lessons aligned with current science standards that challenge you to use the online telescope to collect and analyze data to form your own conclusions. These quests teach you how to explore space with the online telescope, how to capture images to complete the quests, and do all of this in a self-directed manner while completing learning activities that are sometimes a bit challenging. Yeah. What's really awesome is that—
nice. Oh, look, here's the, what are we looking at here, John? This is pretty cool.
This is our quest map. So this shows all of the quests that we currently have available for you to go on and learn about myriad of aspects of the universe. These quests are a great way for users of all levels and members to stay engaged on the platform because they give structure, they provide goals for learning and capturing objects from their collection. You have access to 10 online telescopes that look at fantastic things. And these quests are going to teach you how to follow in the footsteps of professional astronomers, from learning how to capture objects with those telescopes to planning, executing authentic observational astronomy missions that consider various factors that may affect your telescope images. Yeah. The missions themselves, weather, moon's location, because we learned tonight that the moon is rather bright, and
John,
when the moon is
full.
This. Oh my! Look at this! Gosh, look at that! Wow.
That's
thank you, Omaha.
Yes, this is from Slooh member John Larson, Omaha, Nebraska. Looking good there. So I think what John has done here is he's changed the settings on the camera because it was getting darker and darker and darker. And we're only 2 minutes away now, of course, from maximum eclipse, which means it's going to be at its very darkest. But John, let's get back to that conversation. Let's stick on this view if we can, studio, please. So what would happen if the moon was only passing partially through that umbral shadow? What would be different to the event that we're seeing tonight?
Well, if it only partially passed within the shadow, it would be called a partial lunar eclipse. And so you would see that bite start to come out of the moon, but then the bite would never actually engulf. And so this happens sometimes if we remember back to the tilting of the moon's orbit. Sometimes the moon just won't pass completely in that umbral shadow. And we're so lucky tonight to have it. And it's been a bit since we've had a total lunar eclipse. Yeah. And so it's a grand time to be together for it.
It's a smashing view, isn't it? So we're a minute away. So, this is where, we're seeing it as deep into that central umbral shadow, Earth's darkest shadow, as it can get. And goodness me, what a color. I mean, I still wouldn't describe that as red, would you, John? I'd say it's kind of that peachy color down on the right hand side. It's more of an orange, I would say, to me.
Yeah, I mean, I see kind of a gradient in the near Tycho. You can kind of just barely see Tycho. Like, that looks kind of like yellowish to me, and then the opposite side seems more of a reddish, and it's kind of a gradient going from yellow to orange to red. I agree with everybody that was talking about the blood moon. I don't see the blood either, but if it's going to get people out and looking up, I'm for it.
Exactly. Now I'm gonna pick up on something you said in a minute. After we've done a couple of other questions about what you just said about the even illumination of the moon, because there's something that this particular feed really shows us clearly. But you shared earlier the Earth Moon system learning progression, which was a series of quests, and I noticed that Milton's Mama Killer Inca Moon quest was included. Why is that included on that particular learning progression?
So Mama Kia is all about it's still about the moon, so it deserves to be on that learning progression. And we've talked about the different aspects of astronomy, and Mama Kia gives you an opportunity to see how we thought about the universe back then. As humanity continues to learn more and more about how the universe operates and grapples with our ever-changing understanding of our place in the cosmos. I mean, a few days ago, we just took a picture of the supermassive black hole in the center of our galaxy. It's the first time we've ever been able to do that. So as we keep pushing forward in the future, it's essential that we remember where we came from. And so Mama Kia Inca Moon is a perfect quest that does that. It does that for our nearest neighbor. So after capturing images of the moon, you learn about the Inca Empire in South America, how they viewed the moon, the importance to their culture. You uncover a few Inca myths, and you walk away with an understanding that they had, and then you can think about how that's changed, and possibly think how are we going to think about the lunar eclipses in 100 years from now, 200 years from now, 1,000 years from now.
Yeah, personally, I find the linking of stories, mythology, the constellations are still, to me, the best way of learning the night sky. And you learn the mythology behind it, and it makes it easier to point out. It helps me remember a lot of the science because our brains store stories. We're good at storing stories. But anyway, John, some people weren't around a little bit earlier, and what we're going to see in the later phases of this eclipse is that dark shadow coming back again. Now, I've heard people talk about the moon going through lunar phases during a lunar eclipse. It's a common misconception, but do we see any clues that support that?
We can. We can actually see some, well, earlier in the night, we were able to see some clues. I mean, now we can't really see some clues right this moment, but yes, there is a common misconception. And what the key is when there's different phases of the moon, shadows are being cast on the surface, and you're able to see a lot of beautiful features around where the terminator is, which is the day-night line on the moon. When we start to watch the moon leaving the umbra, and we start to see the shadow, the edge of the umbra starting to make its way across the surface of the moon again, if we look closely, we won't be able to see any long shadows being cast. It's literally because the Earth is in front of the sunlight that's bearing directly down on the lunar surface. So if it were actually going through the lunar phases, then we would see a lot more contrast and a lot more lunar surface features, which you can learn all about these lunar surface features in a quest called The Moon Lunar Features. You can learn all about the craters, the Maria, Rima, and other fantastic formations that are on the moon and how they're formed.
We've got a great illustration of this, haven't we? With a couple of photos, because full moons, when the moon is evenly illuminated, not in the case of an eclipse like this, but usually that full moon is evenly illuminated across its whole phase, it does make it really difficult to spot those features without the relief and the contrast of the shadows. It's going to be even more difficult, isn't it, or challenging to identify the Apollo landing sites, which is one of the lunar quests that we've got.
Absolutely. I don't know if we have like a 5 second to show the number 7 studio. Next image, please. The lunar phase, this one. That's right here. Yeah. So right now we're in the full moon phase. So the moon looks like what's on the right, but of course the moon is going through the umbral shadow, and we're getting this awesome, fantastic. We are getting this beautiful redness on the back. And so this redness of the lunar eclipse is what's happening in the full moon on the right. But if you look at the waxing gibbous moon, the inset that's on the left side of this diagram, you can see how since the sunlight is hitting the moon from an angle and not directly down, there's shadows being cast. And now all of a sudden we can see what almost looks like 2 eyeballs and an open mouth going, ooh, in that Maria right there. But you can't really see it when on the full moon.
Yeah.
I hope we can see where those eyes and the mouth are, but that's what I see with those 3 craters every time.
So how challenging would it be to identify the Apollo landing sites then, John?
It would be a little challenging, not impossible, but it would be more advantageous to do it right when the terminators are nearby the landing sites. And again, the quest tells you when the terminator is going to be near those landing sites, the phase that the moon is in, and it teaches you how to go off and schedule your missions to get the perfect Apollo landing poster for once you complete the quest.
And from some of the diagrams that you showed earlier, there's 2 periods each month, isn't there? That people doing the Apollo quest can capture the Apollo landing sites. Is that right?
That's right. When the moon is in a new moon phase, there's, of course, the sun is not shining on the moon. And as we start to progress through the waxing phases, the terminator starts on one side of the moon and completely goes all the way to the other side until it's full. Then when the waning phases happens, the terminator sweeps across the lunar surface again, but this time it's bringing night. So as you can see in this poster here, on the left side of this Apollo landing poster, it's showing the day side on the right side and the night side on the left side. You can kind of even piece out where the landing sites are. The bright colored pixel is a little lunar module sticker, and the opposite happens on the right side. So I just so happened to design it this way, but if you want to design it another way, have it be maybe like more accurate to when the Apollo astronauts went there, you could do that. Or if you want to make it switch it up for either landing site, you can do that too. So what we like to do in these quests is give people as many opportunity to express themselves as they would like to, and that's one way to do it.
John, thank you so much for sharing the fruits of your labor, and other authors like Melton as well this evening. And I would really urge any members, it's a terrific way of learning how to use the online telescope, but while you're also learning about astronomical concepts, because all of the quests, John didn't say this, but all of the quests are directly related to using Slooh's telescopes. On all of them, John, they culminate, don't they, in those lovely posters with the users' images that they themselves have captured using the telescopes.
Absolutely. These quests are going to make, once you're done embarking on all these quests, you are an expert at using this platform.
Exactly.
And the breadth of knowledge that you're going to get from it too, because it spans, it's not just astronomy. We span all different topics and ranges of topics that touch on the beautiful reasons why we're coming together.
I'm doing a getting started for new members session on Tuesday, John. More details of that if you're interested, if you're a new member at the end. What quests would you recommend new members start with?
I would recommend starting with the Nifty Nebula quest. There's this is a fantastic quest that really gets really helps you get your legs with scheduling missions, figuring out, what awesome things are there in the universe. Because if you don't know, nebulae are really beautiful things that we have out there. That's a fantastic quest to start on. There's the R Dynamic Star, which is another fantastic quest.
Ooh, yes.
This quest teaches you how to use the Canary 5 solar telescope, which is very important because as you get further and further into the quest map, you'll find some quests where you have to get a solar shot, and you have to get some nebulae shots and galaxy shots and planetary shots. So the starter quests are the perfect place to start your journey with Slooh, the online telescope, and set yourself up for success for going through the rest of the quests.
Excellent. Thank you, John, so much for enlightening us about Slooh Quest. How about sharing an exclusive with us? What are the upcoming quests you working on and the team working on that are going to be released?
There is a quest. There is an asteroid related quest that I'm working on with Cameron McEwing. He's another one of our authors on our quest team. And this is going to be a fun quest where you learn about how Ceres was discovered, and you learn some techniques on how to figure out where some of these asteroids are going to be, how to capture them with the telescope, and then how to actually make animations out of them.
Ooh, cool.
And see what some of these asteroids look like with respect to the background stars.
Excellent. Looking forward to that one, John. Thank you very much. Feel free to hang around for the round table if you'd like to join us. But studio, could you please go back to John Larson's feed in Omaha, Nebraska? Because I saw there was a little bit of chat going on about the little white and red dots in this image, and whether or not some of them were called hot pixels or not. Now, a hot pixel is something that you tend to get in astronomical images, not daylight images, because they get overwhelmed, but they're basically pixels, photo sites on the sensor of the camera, which just generate a lot of noise. So they generate electrons spontaneously, so they appear illuminated? Well, there's a really, really easy way during a lunar eclipse to tell what's a star, what's a hot pixel. And it's a question of where it moves in relation to the moon. So Slooh Studio did point out there's a few little white spots on top of the moon. Well, obviously those are hot pixels because we can't see through the moon. But the two very bright ones to the left of the moon here, to me, I've been keeping an eye on those and they look like they're getting closer to the moon. So those will be stars, but basically a hot pixel will always stay in exactly the same place in an image with any given camera. But anyway, we are going to take a short break, really short break this time. And when we come back, I'm going to welcome back our community experts for a roundtable chat as we watch the last 30 minutes of this total phase. We've got about 35 minutes, I guess, something like that. We'll look at the timings in a second. But anyway, don't go anywhere. We're going to bring the Slooh community over to you so we can show you what we do and what we chat about normally. Bye now. Welcome back to the last segment of our live coverage of the full flower moon total lunar eclipse. You can throw super moon in there as well, and you'll get the picture. Well done if you've lasted this long, but we're on the home straight, and I'm so glad. I hope you're glad that you've stuck around to see this kind of view. This is exactly what we were hoping for this evening. And John Larson from Omaha, Nebraska, has given us this live feed. We did hop over at one point to one of the other feeds that we had from Nick. Nick is in Dallas-Fort Worth, Texas. And I was pretty sure that in that view of the sky, I saw lightning. I don't know if anybody else spotted that, but oh yeah, look, yeah, so sorry. I was looking at the image rather than the text on there, but oh no, so poor Nick. He'd set up for us tonight to take this. Still got his telescope out, I see. We're ever hopeful, astronomers, of clear skies. But anyway, I know they had a big outreach event down there, their local astronomical society down there. Now, is it me? Or is the moon getting closer to those two white dots? I think it is. Anyway, I would now like to welcome back our community experts who did some segments during the first penumbral phase. We've got Keith, we've got Milton, we've got Gretchen. Keith is Keith is here. I'm interested to hear from each of you at the moment what you've made of this total lunar eclipse so far.
It's been fantastic. I mean, the images are just terrific. We had clouds here, and it's, you know, it reminds me almost exactly of the event that we had last year, where here it rained and rained. It was just awful, and then it got cool at night, and the clouds just blew away. And we've got a beautiful moon outside. The images are just fantastic. You know, I want to invite everybody in the community, you know, if they ever want to do these live feeds, we do this on Discord all the time. Gretchen and I have experimented. And on the Tuesday show, John and Nick both gave live feeds. Nick regularly broadcasts from the equipment that he uses, and just fantastic stuff. And we just see, you know, these images live, that real Slooh members are out, you know, taking the initiative with their own equipment to provide with us here. It's just phenomenal.
It is. It's absolutely remarkable.
And the Slooh telescopes have been fantastic too. You know, we didn't know. I didn't know where, you know, the Canary Islands were going to be in relation to, you know, what was visible and where they were going to be on the horizon, but just a super job. It's been a great party and just great to watch these images.
Yeah, and with the Canary Islands at this time of year, it can be a little bit dodgy, you know, as far as the weather's concerned. You're in that funny period of time, even though we've got the Canary Islands Observatory in the Northern Hemisphere, the Chile Observatory in the Southern Hemisphere. There's this tiny little period of the year where actually both observatories can be affected badly by weather at the same time. Usually kind of one is the backup to the other, but we've been very lucky tonight because we've had live images coming in. Oh, there's the Chile 3. We had a quick peek at, so that's quite good. So we sorted out finally the image squashing in Canary 3. But one of the things that's been interesting there is that we've seen quite a pronounced lack of color in Canary 3. So that's quite interesting. That view.
Over to Gretchen's feed, she had some terrific images too.
Yeah. So, well, Gretchen, coming over to you, how is the event still there? You're the lucky one among us who's actually able to see this with your naked eyes.
I'm feeling like super grateful for being here. You know, last November,
That's lovely.
Did the live feed from, I was telling my friends, I said, you know, the last live feed I did literally sitting in my driveway with a table and extension cord from my bedroom with my dog. And it was great. I said, but oh my God, I'm sitting in a comfy chair, you know, with all the luxuries of the world, and the eclipse is right behind me. And so it's pretty fantastic. It's been really amazing. We've had a great view, a little bit of haze, you know, but it made it interesting. That first photo that I sent in with a bit of the clouds kind of mysteriously marking it was really beautiful.
And remind us where you are.
I am in Portal, Arizona, and this location in Arizona is it's particularly known for its dark skies. So they do have a place called Sky Village, and everybody that lives there pretty much has their own observatory with either a roll top or, you know, it's crazy. It's a sight to see.
Jealous.
They're all down there right now, sitting there looking through their own like giant telescopes.
Exactly. But as Bob Berman said, you know, lunar eclipses are something that is good with the naked eye. I think it's great to have a pair of binoculars, but you know, I often see at the moment, you know, photos of events, you know, concerts or special events, whatever, and everybody's holding their phone up, looking at their phone. And this is great because Keith's clouded out, I'm clouded out here in England. I could not have seen this tonight with my own naked eye. But for those people who have got clear skies, it's still worthwhile getting outside and seeing this with your own naked eye. Especially,
I gotta agree with you, Paul. I mean, I think that's the big reminder here is, you know, and I told people, I'm like, yeah, catch it on Slooh. I said, but you know what? In Arizona and these certain areas, you're going to have a live view. So I will not be offended. I said, please get your buns outside and watch it live, because you watch it with your eyes, you know, binoculars make it even more spectacular if you want to look at details, but you just could sit there in a lawn chair and just
take it in. Just take it in. I haven't seen a lunar eclipse in person for many years now. In fact, I think it's the last one was probably the first one I covered for Slooh, where I went to Cyprus to provide a stream for it. But look, we have seen one of those stars disappear, so we know that one of those was a star, but we're still seeing a couple of those little red blotches there. But I would like to hear from Milton, because I have to say, Milton, you know, your storytelling about the Incas earlier was lovely to listen to, but what it's actually done is it's changed my thoughts when I'm looking at these live image streams. So imagine being an ancient before we had the kind of understanding of the mechanics of an eclipse like this, and just imagine what they would have thought seeing the moon change color like this. It would have been terrifying, probably.
Definitely. I still have one more story to tell, and this is precisely the one you see in the background. I think Studio can show you a bigger picture on 3B.
Yes, please.
I'm so glad you're going to share that, Milton, because I'll share it later, but it totally goes with what I was talking to my friends about when the moon disappeared. So this is so timely.
Excellent.
Yeah, well, they were really frightened, but not because something was going to happen to them directly, but to their goddess, right? So there we go. We have a lovely image of the big cat attacking the moon. This is also in my web quest referred to as the jaguar attack, and the jaguar is not a cat you will see in the Andes very often. But occasionally you would, and they understood that this was a very dangerous animal. The only animal, of course, that could reach that high. And so, the animal now is exactly jumping on the moon and, destroying her basically. So what they do is they pick up anything that makes any noise, their voice is included, and they will go out and try to scare the cat away. And it's this very interesting communion between what goes on Earth and in the skies, that they try to scare this cat away and feel victorious when they do, because eventually this will pass, as we will see in the next 30 minutes or so. And their happiness after the victory is incredible. They have defended their goddess, and hope this will never occur again. Something that again they couldn't really predict in the past. That is what they felt when total lunar eclipse occurred.
Well, Mill and I ran outside and I didn't see the moon, and I said, "Oh my God, you guys, did the jaguar eat the moon?"
Exactly what they would probably have thought, right? Did the jaguar actually kill or eat the moon? But lucky for all of us, they were able to preserve the moon. And the moon for them, and as it should be for us, because in general we consider the moon very romantic sight, and it's around there. But have you ever considered what would happen to the Earth without the moon? In my physics class, we studied that without the moon, for example, our Earth would be rotating every 10 hours or so. And what that would do to the water of the planet, it would be a very wet mess, right? And our planet would not have been able to even create the situation for life to emerge. Instead, the moon managed to slow down the Earth, give it the time really to process the tides, and give our planet the time exactly to combine those chemicals and eventually give life to the planet. So that's the communion that our ancestors had with the moon, with the sun, the giver of life. And I don't think they were too far away from the truth in that matter.
And it's very unusual for a planet, certainly in our solar system, to have a moon of this size in comparison to the planet. Keith, I don't know if you want to come in on that, but what Milton was saying there is the moon has basically stabilized the Earth, because we see some of the planets have very changing axial tilts, which gives them extreme seasons and things like that.
Our galaxy.
Yeah, it's not just the moon.
Sagittarius.
We know
where located 25,000 light years away.
Somebody's got the mission interface open. No audio live. Carry on, Keith.
It's not just the moon. We know that Jupiter does the same thing. And not only Jupiter, but the so-called shepherd moons of Jupiter. Jupiter is, responsible for much of the mass of the solar system. In fact, I think it's bigger than more mass than all the planets combined. Yeah. But if it were not for Jupiter keeping sort of things in order, and the shepherd moons of Jupiter, the moons of Jupiter do the same to Jupiter as our moon does for us. So, yeah, I mean, there's just so much that we think about in this incredibly beautiful gyroscope that is space. I'm glad that Bob Berman talked about the tilt of the moon, but the orbit itself is actually changing. Yeah. And when we think about the sun and the Earth and the moon, that's a great way, I think, to bring home this idea that everything is in motion. When we look at these flat two-dimensional models, as good as they are, they don't really give us the full impact of what's happening. You know, to think of Uranus being tilted at 97 degrees and moving sideways, and, you know, in a retrograde motion, you know, moving clockwise, it just, to sit and just think about the solar system is just such a beautiful, beautiful thing of this just, you know, whirlwind of you know, this gyroscopic action of everything revolving around everything else. And then to bring in the fact that the sun is moving with vortex motion, making a beeline to the great attractor in Sagittarius. So to think that this whole thing is itself moving, even though it's, you know, so far away, it doesn't appear to move, but it is. So it's just great stuff to think about.
There's a huge amount of weirdness in our solar system. And, you know, when I was a kid, well, we didn't think there were very many solar systems around, but, you know, we now actually, it's pretty difficult to find a star that doesn't have its own retinue of planets orbiting it. And we know, I think, you know, already there's some really weird stuff out there. Super giant planets orbiting incredibly closely to their stars. I think we've even seen planets orbiting binary stars, two stars themselves, which are in orbit, but they have planets orbiting both of them as well, let alone the moons that those planets may have. And it's this celestial clockwork, which has always fascinated me. But tonight kind of brings together all of these things, doesn't it? It's those coincidences of the geometry of our Earth, Moon, Sun system. It's also affecting us. I mean, I look at that with such awe and wonder, but then in a split second, I'm fascinated by the science that John was talking about and you were talking about, Keith, with the refraction of light and Rayleigh scattering and stuff like that. You know, it's just so much in the same melting pot. And that's what I love about a solar eclipse and a lunar eclipse. It has every single perspective that so many members, you know, share: the cultural, the scientific, the historical. You know, look at the Apollo moon missions. You know, there's so many different perspectives, and we all seem to come together and we all get on quite well, don't we?
Yeah, we have a lot of fun in these star parties, and it's, you know, during lockdown, I think that so many of us have just, you know, gotten to know each other and become friends. So we saw it with some of the other shows that we've, you know, been part of. It's just great. It's just a great community of people that are here on Slooh. It's, you know, in all truthfulness.
So talk about the community. We're going to be running for another 20 minutes or so here. But then some people with more energy than I've got, because it's 20 to 6 here in the morning, you're going to decamp, aren't you, over to our Discord server, which is where members hang out in what are called houses. So people with different interests and stuff like that. We've got a whole student one, which is dedicated just for students. And I think we've got a nightscape one that Sonal is involved with. So if you've got a DSLR camera and you're interested in getting out and trying some nightscape photography, it's easier than you think. But there's a whole group of people there to help you out. Now, Gretchen, you were thinking of starting something up, weren't you, to kind of focus on maybe some of these more spiritual, your woo.
The science plus woo, and really talking about, and I've chatted with Milton, and Milton has wanted, I think he'll join in with me, but we really wanted to talk a lot about how music or poetry and writing and creativity ties in with the science aspect of astronomy. So this whole, how else do we express our love and passion, or what does it incite within us, right? What does it bring out, and how does that tie? You know, I was thinking today as I was driving down here that so many archaeological sites and so much history in Arizona, like with petroglyphs and pictographs and these images on these stones that are thousands and thousands of years old, that connect community in the cosmos and conscious over time, right? And it's the same thing with astronomy. As we learn and expand our knowledge, it's a continuation of that. So that's the house I'm really looking at, is, you know, what are these different ways that we come up with prose, music, all of that kind of stuff, and relating it also back to the mythology, the stories. I just think it'd be super fun.
I do love the storytelling.
I agree.
My bookshelf up here. I'm just looking up, and you see a selection, and there's a whole bundle which are Richard Dawkins there. You got all manner of pure science books, but then I've got the Age of Fable up there, and constellation books, and it's star names, the lore and meaning. It is so difficult, and I don't think you'd even want to try to disentangle those elements of culture, mythology, history from astronomy. And frankly, it's what a lot of my joy with astronomy is. I've got some antique astronomy books here as well, and I love looking through those to see what they were writing. Their explanation of a lunar eclipse was 100 years ago, 150 years ago. Now, our understanding of lunar eclipses has been quite good for a period of time, but thinking about things like the Andromeda Galaxy, it's written up in most of those books as the Andromeda Nebula, because we didn't even know that there were more galaxies outside of our own Milky Way. And it's fascinating to see the progress of our understanding. And every single week, John, I don't know if you want to come in on this, because you mentioned something earlier about the big,
I think he does. I think he's got something to say.
The big release this week, of some new imagery. But it's one of the joys, isn't it, of astronomy? Every time you think, yeah, I'm getting on top of this subject, something else comes along and it's new, and it keeps it so fresh, doesn't it, John?
Absolutely does. And it changes our perspective of our view in the universe. So that supermassive black hole, which is in the center of the galaxy, which our sun is orbiting, how big is it? How big is that little donut that we saw? Well, if you look at a full moon image from Slooh's telescopes, imagine a chocolate covered donut, little ring donut, normal donut, throw it on the surface of the moon. That's how big the supermassive black hole that looks like in the sky.
Oh, nice one. There it is.
That is how small that is in the sky. And we took a picture of it.
It's beautifully color coordinated, isn't it, with this lunar eclipse? Look at that.
It's like they planned it.
I just noticed actually that star that's reappearing from being occulted by the moon at the top.
I know, this star is all like, hey, look at me.
This is just the lunar eclipse that keeps on giving. So, John, where do you get your buzz? I mean, you're a qualified PhD doctor of astronomy. Where do you get your buzz and big enjoyment from in astronomy? What gets you excited about astronomy every day?
Gosh, I mean, I don't know. I've been into space and astronomy kind of my ever since I was really young. And so it was kind of trying to find my way to learn more about the night sky. I mean, for me, of course, so I'm a trained scientist, but I don't just look at it in that lens. I love seeing how has this changed humanity? How have we, how has the night sky affected us? Because before there were civilizations, all we had was the night sky to look at. And so really we've all been astronomers since the dawn of humanity. And so we just figured out that there's a bunch of other things that we can do on this planet, but all of those other things lead us back to looking up again and seeing that. And we've always been doing that. And so it's so to me, it's the ensemble. It's everything all together that makes it for me. But the science is a lot of fun with it.
And I can confirm that because writing the web quests that had to do with the topics I presented, John gave them the balance they needed for the scientific part. And, while working on that, I found in John this person that has those two, elements in everything. He's as careful a scientist as I have ever met, and also a person with a deep heart for those stories and those, connections with the past.
Thank you so much, Milton. Really appreciate that. I've really loved working with you too on these web quests. They've been fantastic. Love all of our quests we're making.
You know, I love that you guys are sharing this because I think it really points to the community of Slooh from like all levels. You know, everybody's working together, and it's this collaboration that is echoing, of course, what we're talking about with this eclipse and what makes it so special. It's a collaboration of the universes working together in alignment. There's this massive alignment happening that creates this eclipse. And that's what also is happening like with Slooh and the communities and the houses and everybody getting together. You know, it's just so perfect. It's like awesome.
It is.
We're growing together, yes.
We are about 5 minutes away, maybe 6 minutes away from the end of the total eclipse, which is quite interesting because look at this, you know, we're saying what we were saying about an hour and 25 minutes ago, hour and 20 minutes ago, when we were still seeing this very, very bright region. It's actually started on the right, and seeing this huge graduation as the moon is moving out of that deep umbral shadow. And this is where everybody who's doing a feed, including John Larson, John, thank you so much, from Omaha, Nebraska, Slooh member, giving us this wonderful feed. This is where in a solar eclipse, you start to panic because everything's happening by the second and you've got to change your settings on your camera really quickly. It's still happening. And I'll tell you, it's still nerve-wracking. You know, so John's done this, and Nick, who unfortunately was clouded out, and Gretchen's doing it. You know, it's nerve-wracking setting up one of these feeds, and you start seeing this. When do you change your settings? When do you decrease the exposure level so that, you know, it's not all blown out? But, you know, we're seeing this huge, you know, gradient across the image. And look at, in fact, that's something that I think John's feed has given us tonight that I haven't noticed in a previous eclipse. I think it's the zoomed in view. It's what I was saying to Bob Berman, the discrepancy between the contrast between the light regions and the dark regions. I don't think I've seen that before. Has anybody else?
I don't know. Can you clarify like the discrepancy that you're talking about?
Well, look how dark the moons are in comparison. If we were to look at a normal image of the moon in grayscale without all the color, I don't believe there's that amount of contrast between the illuminated areas and the dark Maria as they are. It just looks like there's more contrast to me than normal. I don't know.
Well, you know,
well, you know, it's like my one friend he's seen a ton of eclipse just like I have, and he just feels like this one is more intense and more interesting. So, yeah.
Interesting. And there's no volcanoes.
It's a little bit more comfortable to the eye because, you know, when you see a full moon, there is a lot of brightness. Even if you look at the telescope, there is a blinding brightness. But this one is softer, it's more comfortable to the eye, and you can distinguish a lot more quickly.
That's a great way to put it. Softer and more comfortable to the eye.
I think one of the things we have to think about too is it is still a full moon. And when we have, you know, the full moon, we don't have shadows and being cast and having those types of things. There's no terminator. It's this, whatever sunlight there is, you know, hitting the moon face on. And we get that effect of the mare, you know, the idea that the titanium deposits, which is what makes them darker, like Tranquillitatis has a lot of this titanium. So I think that's just the darkness, the inherent darkness of the seas sort of still shining through this reflected event light, you know.
But you contrast it to this feed, I think it's far more even. I don't think there's as much contrast. I don't know. It's so difficult to compare because so much is down to the telescope being used, the camera being used. But I think there's some terrific contrast in that. Those dark Maria looks really, really dark. It is, isn't it?
John's feed, like amazing. Wow.
Yeah. I think it's been my favorite feed actually of the entire evening. So nice work, John. I hope John can hear us and hear our appreciation.
He will for sure make sure he knows.
Exactly. So a come on then. What else would everybody like to talk about in our remaining few minutes? Actually, we ought to do a countdown, really, because so the full eclipse, the total eclipse, ends at 53 minutes and 55 seconds, which is a couple of minutes away, isn't it? Oh, we've got a time. It is. Got a time code up there. So okay, so it's a minute away.
1 minute. Yeah.
So I do think we should go to the other view so that we can see the bright region at the bottom, and there you can see it. You know, this is the other thing as well, which is difficult, isn't it? To compare different image feeds, because they're, you know, cameras are rotated slightly differently. At least with Slooh telescopes, we always know they're rotated in the same way, so you can compare them. But look at that. I mean, that if they change the exposure on this camera now, I think we would lose all of that color entirely, just as we saw it kind of come in at the beginning. And it is so difficult adjusting your camera settings to hit the sweet spot. But that's looking beautiful, isn't it?
Yeah, that's interesting you said that, Paul, because when I saw it earlier, I'm like, oh, there's no color. And when I started to change exposure, I'm like, oh, now there's color.
Yeah.
So, and then I actually could see it. At a certain point, you could see the color, but a lot of it had to do with those camera settings.
Yeah, and if you change the white balance as well, that happens. It changes it dramatically. So that feed says that was it. That was the moment. 55 seconds was the end of the total lunar eclipse, but we're still seeing this glorious color. It'll disappear quite quickly now. That's pretty cool, isn't it? I love that. I love that. What a marathon of an event. So this is 55 seconds, bang. So I think there's a bit of delay on that one. So John, well done. You've got the most current feed. You got there. You got to the end first. So. Favorite part, everybody, of this particular lunar eclipse?
Gosh. Well, I mean, if you're going to talk about just looking at the eclipse, I was really loving this sort of hide and seek of the stars.
Yeah.
Where it was happening with the eclipse. That to me was super fun. You know,
and we rarely talk about it. We rarely talk about the stars suddenly becoming so apparent, because of a normal full moon, you know, totally saturates the sky around it. You can't capture anything. You can't just look up at any moon, actually, and you'll very rarely be able to see any stars within a certain radius of it, because it's just overwhelms everything. But here we've got, it's dark enough so that we can still capture the stars behind, and it kind of really illustrates nicely, doesn't it, the motion of the moon against the background stars. And it's actually one of my favorite things, which people don't look at during totality of a solar eclipse, when we normally see the planets popping out, you know, because usually there's Mercury and Venus, you know, which are on either side of the sun, and bang, they suddenly pop out during totality, and then they're just snuffed out as soon as totality stops. So Milton, what's been your highlight of today? I have to say that my highlight has been your storytelling, so thank you for that. But what's your highlight of this eclipse?
Well, from the other side of this, I totally enjoy the experts talk and, you know, feed my thirst for the technical aspect of, you know, what we see. As with everything, it brings balance to people, right? So, yeah, I totally enjoyed, you know, listening to astronomers talking about this favorite subject. And, you know, I sent the link to my students, so I hope they are watching, and they will tell me very soon, I guess. And of course, you know, I will love to hear what they took from this presentation.
Good. Well, we look forward to hearing what they thought. How about you, Keith? Highlight of the this eclipse?
Well, yeah, I mean, besides just the event, it's just getting together with everybody here. I always love listening to Milton, and of course you and Gretchen and Dr. John and Bob Berman, of course. It's just a treasure to have. So, you know, the event, and then also the community. Normally I would be outside, you know, looking at this myself, but I just, really, really enjoy listening to everybody talk. It's just great. And Gretchen, I'm going to let you give the plug for the Tuesday show. We get together like this once a week. So Gretchen, why don't you tell us?
Yeah.
Oh my gosh. Okay, so Tuesday night, we get together. It's a community gathering and it's super fun. And Keith mentioned at the beginning, and I'm going to say it again for those who weren't here. We have what I call our Sunny report from Jenny, who talks all about everything solar, and Keith does a wonderful planetary report. And we have Dark Sky Mac, we have Sonali, we have Hank, we have all of these people who join us, that it's become like the cheers for astronomy, right? So we all like join in and we have a cup of tea or a glass of wine or whatever your pleasure is. And we just talk about interesting things in the sky and the cosmos. It's super fun. And last week it went, Nick is there. Nick is great. And John, I mean, so many people, I'm probably forgetting names, but it went on for like 3.5 hours. I was like, okay, everybody keep having fun. I gotta go. But join us there. It's just a lot of fun and you learn a lot and you have a lot of laughs, and we're just really getting to know each other as fellow humans, which is probably the best part.
Yep. So that's Tuesday, 8 p.m. Eastern time.
Tuesday, and we don't keep you on 3.5 hours. The show is actually only set up for an hour. Gretchen and I prepare an hour's worth of material. It's just that when we get in the same room with everybody, we just kind of start talking.
No one wants to leave. It's like awesome.
It was a great party. I just enjoyed listening to everybody here. I loved it, Paul. Thank you so much for having me.
Exactly. It's this huge variety of perspectives I love. How about you, John? What have you enjoyed this evening? It's been great listening to you sharing Slooh quests with what will be undoubtedly a whole bunch of people who never heard of Slooh before. It's normally described as the best kept secret in amateur astronomy and education.
It absolutely is. And I'm glad that everybody who's tuned in, that you've now learned the secret and now you can act on it.
Exactly.
Now, my favorite part of tonight was actually already said. The fact that we are all coming together on this globe. There are people who are watching right now that, of course, where most of us are, it's cloudy. It's cloudy here in Las Vegas too, unfortunately. I ran outside not too long ago. But there are even people who don't even have the moon in their sky right now that are enjoying this. And so we really are this global community coming together, enjoying these fantastic events that, they should be celebrated as a holiday. And we're doing that right now, actually.
Yeah. And we're going to be doing more of these public star parties as well. So all of the community stuff's still going to go on. But if there's something interesting happening in the sky, then this is a great way of us sharing with the world, hey, listen, we're over here, come and join us. And
as
that's
it did
exactly
in the
what
past,
everybody can do.
these star parties bring people together. The moon, for example, brings people together. I imagine that this is how language started, people getting together, looking at the skies. To illustrate this, I can tell you, for example, my family is all over the place. My brother was here in the Zoom. My wife and daughter were in Santa Cruz, Bolivia. The other part of my family are in La Paz, and my younger daughter is right now in Michigan. So imagine, we are united by this event.
Yeah. A few people commenting, we're getting ready for the solar eclipse 2024. That was Nick Rotundo saying that he's getting set up for that. Nick, I'm sorry that you had cloudy skies, but thank you so much for setting yourself up down at Dallas Fort Worth to bring us a feed. But we did see some good lightning. Look at that. It's got the weather station there. Still hopeful, aren't you, Nick?
Well, you know what? Nick is in line for the solar eclipse where he's at in Dallas. So we're all going to just hop in vans, get on a plane, and we're going to party at Nick's backyard. Thank you, Nick.
Well, we had an email from somebody the other day to Slooh support saying, you're my last port of call. I don't know who to ask. I want to get married, and having experienced the eclipse a couple of years ago, I want to get married at the moment of the total solar eclipse in 2024, but I don't know where to go. I don't know what the timing is. Anyway, I emailed her, and she's now got all of the information that she wants. So who knows, we may actually be broadcasting live, as we did for the last eclipse, on site, but maybe at their wedding, because they actually want to exchange vows at the moment of totality. So that would be quite a cool thing to witness, wouldn't it?
Super cool.
So, anyway, listen, we have run out of time. Now, if you are an absolute enthusiast, you can cross over to our Discord server. Milton, Gretchen, Keith, are you hopping over there yourselves?
You know, guys? I have to pack up, and I'm moving down. My friends who live, they've got a couple of different places here, so I've got to pack up all my camera gear and everything. And I'll probably hop on, but it'll probably be, I don't know, 20 minutes or so. So if Keith, you're available to hop on now, that'd be spectacular.
Yeah, I guess we'll stop over for a little bit.
Cool. Yeah. Okay, so anybody hop over to the Discord server. If you want to do that, then there's instructions on how to do that on the website. But for now, I'd like to thank all of our special guests. We've got Keith, who told us all about lunar eclipses, a bit of an eclipse 101 right at the beginning, so that was brilliant. Milton, your storytelling, brilliant. Gretchen, your first-hand reports of the eclipse down there, I am slightly jealous of you. Dr. John Beauvert, who's told us all about how students of all ages can use the online telescope's quest to explore the universe and learn more about astronomy. And of course, our astronomy author and one of our favorite guests, Bob Berman. If you want a fascinating read and a fun read, then check out Bob's book called Zoom, not related to what we're doing now. I'd also like to thank our feed partners tonight. Nick Rotundo, I'm so sorry that you were clouded out, but thank you so much down in Texas. Who knows? Never give up. You know, you might get a couple of minutes of a clear sky with that little moon popping out. John Larson, you gave us a fabulous feed today from Omaha, Nebraska. I really, really enjoyed your live feed. That close-in view was absolutely brilliant. Gretchen, thank you so much for your first-hand reports and the images that you were sending over as well. And of course, our observatory partners at the Institute of Astrophysics of the Canary Islands, skylive.tv, we're still seeing their feed. The moon is getting really, really low now in the Canary Islands. It's probably down to about 15 degrees, I would guess. So that is likely to get a little bit fuzzier, but look at that. That's really starting to kind of burst out on one side, isn't it? Anyway, we've got loads coming up over the next week here at the Online Telescope. If you've enjoyed this event, or if you've joined specifically for this event and you want to really quickly learn how to use the Online Telescope yourself, and join me on Tuesday, May 17th, 7 p.m. Eastern, for my student and family member getting started session. I'll just show you all the tips and tricks I can to get you started really, really quickly. Then later on, an hour after that, join members for their weekly, it's called, they didn't actually say what the name was, but it's Tuesdays, Let's Be Done by 10 with Keith and Gretchen, star party over on the Discord servers. That's Tuesday, May 17th at 8 p.m. Eastern. And if you're an educator or parent and you want to learn more about our educational platform to use in your classes, then join Dr. John Beauvert for his online telescope in your classroom webinar, and that's on Tuesday, May 24th at 7 p.m. John's going to be taking you through the Quest platform and how you can use that in your classroom. But that's it for now. I hope you've enjoyed our live coverage of May's glorious full flower supermoon total lunar eclipse. We hope to see you in the Slooh community as we do this stuff every single night. So thank you very much, everybody. Take care. Good night.
Bye-bye.